Okay, I guess it's time to start this workshop or short course. So thanks everybody for coming. We have an interesting program for all of you. We're going to start off with some introductions. So I'm Paul Wessel, University of Hawaii. I'm a professor of geophysics. I do plate tectonics and doing a lot of coding. It's my life has been the last decades and three. And we have Leo. You want to say a few things?
Hi, I'm a postdoc at UH as well. I'm working with Paul to do the Python bridge with GMT. I'm a geophysicist originally from Brazil. We'll be in England soon.
Dondon?
I'm Duno. I'm from Geodesy University. I'm a postdoc.
Great. Yeah, Joaquim.
I'm Joaquim. I'm from Portugal, University of Jolla, a geophysicist. GMT for some time. Also doing lots of coding, and the geophysics part is more modeling and plate methods.
Excellent. I guess Eric?
I'm Eric. I'm a postdoc from here. I'm a user and developer, technical stack. So I'm more of a SAR and Geodesy.
Yeah, probably some of you are going to take the class on Wednesday, the GPTSR class, so some more Eric. Might as well have Dave say something since he's the boss of everything.
I'm Dave Campbell. I'm a professor here at Scripps, and I'm here to learn GMT6.
We all are. Great.
Just 1 day ahead of you.
Yeah, that's right. Staying 1 day ahead of you guys. So those of you on site, I guess we'll start on this table and go this way, if that's all right.
I'm Cassie. I'm an incoming graduate student at University of Arizona.
All right.
I'm Sam. Cassie and I are going to be working in the same lab at University of Arizona for tectonic geodesy.
Hi, Amber. I'm a second year grad student at Unix.
I'm Mel. I am my second year at CU Boulder.
I'm Ignacio Garcia. I come from Ensenada. I come from Insets. I'm Geodesy. I'm studying master in seismology.
Hi, I'm JK. I'm second year thesis student at Scripps University. I study geodesy and geophysics.
Hi, I'm Mario. I study physics. I from Peru. I work in the Institute Geographic in Peru. Yeah.
Hi, I'm David. I'm starting a master's at Sacramento State University.
I'm Spencer. I am from CU Boulder. I knew I recognized you somewhere. I'm a research tech and I do hard rock geochemistry.
Ooh.
So don't know why.
Serious stuff.
Hi, my name is Jorge. I'm from U.S. Air Force in Florida. I first did spaceborne radars at the University of Massachusetts. So now I'm a seismologist and I'm looking forward to learn GMT later this week.
Good.
I'm Lauren. I'm a graduate student at University of Hawaii, and I'm studying geodesy.
Great. Welcome. So the online folks, if you can hear me and you want to say a few words, do I unmute myself for that to happen? So just, yeah, you can just wave and put your mugshot up and wave. And I guess not. Oh, there you go. Hi.
Hey,
Hello.
can you hear me?
I can hear you.
Yeah. I'm Mohammad Reza from Iran, and I'm PhD student of seismology. And currently, I use the GMT4, but now I want to learn GMT6, and also I participated to GMT SAR course, and that's this. And I'm very happy to
I'm glad you can make it. Anyone else want to say a few words online?
Okay. Hi. Can you hear me?
Yes.
Yeah.
Hello.
My name is Suen. I'm a PhD student in the Australian National University. My current project is about investigating the dynamics of the active tectonic processes in the eastern Indonesia by combining the GPS and the INSET data. And because of some visa problem, I cannot be here in person, but I'm glad to join you guys in virtual. Yeah.
Great. Let's see.
Hello.
Hi.
Can you hear me?
I can hear you.
Yes. I am Juan Villegas from Peru. I am working in Geophysical Institute and working in crustal deformation with GPS, and glad to share with you this course. Thank you very much.
Great. Glad to have you.
Hi, this is Fran. Can you hear me?
Yes, we can hear you.
I have a BS in geology, and I work with NOAA with the National Geodetic Survey, and I'm in Boulder, Colorado.
Very good. Anyone else? All right. Very good. All right. So let me get rid of this thing here. So this is a schedule we have planned for you guys. Quite interesting. This is the first time we're doing this kind of course, and the first time most of the developers are actually practicing GMT6 modern mode. So we're just slightly ahead of you guys, and hopefully we won't run into too many bugs and that sort of thing. But basically, we have auto breaks in the beginning here. We're going to go kind of slow. There might be some install problems. We'll get to that. But hopefully everything will be fine. GitHub was down and is still maybe down. That's not helpful. The GMT server for Subversion and a few other things is down. Perfect timing. But we're here. So we should all be able to figure it out. Let's see. So I should say this before I forget. We go to the GitHub page for the workshop, the short course that you all are familiar with. Leo put a link on the bottom there to all the slides. So all the slides that we're going to be using to talk about GMT, some background stuff is available there. And because it's not very helpful if I put the slide up and then I switch back to terminal and doing stuff and then back to the slide and so on, it's going to be really annoying. So it's good for you guys to just have a browser window with the slides. You can shrink it down a little bit, still readable. So you don't depend on watching my slides. I may put them up because my habit is to put slides up, but we'll try to do a lot of stuff in terminals and in the Visual Studio Code editor, which is also a new thing for me. So everybody else found the GitHub page and can find the link to the slides and it's working? Right now I'm on the introduction part. Yeah, there's little chunks of slides for different things. So we're on the introductions. So it's helpful if you have that link and you can get to it. And the other instructors can remind me. What's that? The random animals. Oh, these guys here, yes, I do. Yeah. I can't tell what kind of random animals. That's good. All right. The way we're going to run this stuff is we assume, based on the survey we had, that most of you haven't done a whole lot of GMT stuff. And if you have certainly haven't done GMT modern mode. So we will assume that we start from scratch. We don't have much background for everything, for Bash, running GMT scripts, all that stuff. So we'll go really slow in the beginning, and then hopefully each session will sort of build a little bit on the previous session so that there is some skill build. There's a whole bunch of instructors in the room, so there should be a lot of one-on-one attention. Where are the sticky notes now? Okay, so Leo has sticky notes. You're all going to get at least one red and call that green. Just take one each.
One of each.
Yeah. So the way it works is that if you're running into some problem and need help, put the red sticker up on your laptop so you can see it instead of trying to get my attention because I can't see well and hearing is gone. So it's better the other people can see the red stickers.
This means everything's okay. If you're having trouble, take it down and put in the red one. And if you see a red one, we'll come running around.
Yeah.
There is a red one here.
Yes. No, I'm not entirely sure how this works for the online participant with the red and the green sticker. Is there an equivalent? They just have to flag us. Yeah, Melissa will notice that someone is having trouble and let me know. So that's good. All right, so for most of these sessions, we'll have to go through some background. We can't just delve into typing code, right? So we have to have a little bit background. It's sort of just a few slides usually for most of the sessions. And then we'll do some very simple examples together very slowly and write scripts and run the scripts. So we're gonna, almost everything we do, at least all the GMT examples, we're gonna type them into Visual Studio Code, unless you have switched to another editor. It's not really important, but that's what we're gonna use at least. We're gonna type the script into the editor, we're gonna save it, we're gonna make it executable, and then we're gonna run the script on the command line as a command. We won't be typing GMT commands into the terminal because they're all going to be at least 3 lines, and it's sort of tedious if you have a typo to start over and kill the session and all that stuff. So we'll start very simple things, and then, as I said, we're going to add more complexity as we go along. So tomorrow is where most of the geodesy parts will happen, right? Where we do some seismology and some geodesy. But today we've got to get the basic skills of making plots, learning how the GMT scripting works. So, and then towards the end of tomorrow, we're going to have a project decided entirely what that will be. It's going to be up to you guys what you kind of want to point and what would you like to accomplish as the final project. Start thinking now, yeah. So if you have a data set, you're working on a problem, you want to make a map or something, we have like 90 minutes for the final project. So can't be too ambitious, but but it's okay. It might be ambitious and you run out of time. That's also okay. And you can get a lot of help from us while you're here. So that's sort of the lay of the land. I went through that. Got email this morning. UNAV CVO, that's a new one. UNAV Co. There we go, live edit. So this short course is all UNAVCO short courses are covered by the UNAVCO Code of Conduct. There's a link here to the full explanation. But basically, like all these code of conducts, just be reasonable, don't be rude to other people, don't be an a-hole, right? We're going to manage that. So I think we won't have to expel anyone. I'm not sure how the expelling works, but has that ever happened? No, it never happened. So don't be the first. All right, so here's some of the rules we have. We're gonna do everything in Bash. All right, so I have my Bash shirt on, born again believer, born, that's a joke. If you are not familiar with Bash and you spent 10 years, 20, 30 years doing C shell, you're welcome to auto-translate into C shell. We're not gonna stop you doing that, but we're not gonna provide multiple language support for shells, right? So we're gonna stick in Bash. We recommend that you switch to Bash if you do something else. It is way better. This webpage, you can Google this, why Bash over C shell, and get lots of, like anything else on the internet, you get very passionate views on why you should be using this or that shell. All right, I already said this, we're gonna write scripts in editor, make them executable and run them. We'll talk about those steps. Oh yeah, so the data files. So most of the data files I think will be remote files on the GMT server, which should be up and running. It's not that server, that's down, a different server. And we also said we have all the files on thumb drives. I'm not sure if we have that really, but we have all the files, at least on the hard drive somewhere. So if you run into trouble. But in the beginning, we aren't actually going to use any data sets that you don't already have in the coastline stuff until we know what we're doing. So that's sort of the plan with that. For the tools, you need to be able to open a terminal. So if you have never opened a terminal, now it's a good time to find where the terminal app lives, because we do need a terminal. And again, red stickers if you have trouble with finding one. Text editor, we recommend that it's Visual Studio Code, which is available for all the operating systems, but If you don't want to do that and you have your own favorite thing, that's fine. You're on your own. Do whatever you want. And browser, yeah. So you already have the slides available to you. We are going to get into the GMT documentation pages and have that handy when we get to it, because you need to look up, how do we run this tool? What are these options? There's a lot of options in GMT that most of us can't remember, so we have to be reminded by looking at the documentation from time to time. Yeah?
So if I have Sublime text editor, is there going to be a difference between that?
Now, we won't do anything that's specific to any particular editor. We're just going to do dump typing, so that's fine. Sublime is good. Okay, so that's the end of that introduction section. And the next one is install help. So I guess we are slightly ahead of the schedule, which is good. We're going to fill the time with me talking stories. It's not a problem. So I guess this is a good time to put a red sticker if you are not having an operational GMT 6 installation. That's right. And then we'll work on that. So I guess there's or anything, any problems. Can't find terminal, Visual Studio Code is not acting up, where are the slides, anything like that. We have plenty of time to deal with that. Okay, it's 10:15. We're gonna get back to it. So we'll talk a little bit about Bash and some Unix basics. And clearly, if you have never done anything in a Unix terminal, there's a little learning curve in the beginning to do basic stuff. We're going to try to keep the Unix side to a bare minimum, but we got to do a few things. If you want to learn more about Bash, there's a very nice online tutorial at Software Carpentry, and it's like 3.5 hours, I think, something like that. So you can do this at night, if you want to catch up and learn a lot more. But we're just going to do some highlights here. So we'll just sort of talk about what are the Bash skills you really need to know to function in this class. And then we'll talk briefly about GMT, some sort of overview perspective. And we'll delve into GMT modern mode scripting, which will be a first for a lot of us. Actually, we were a little ahead of you, but it'll be new. And then we're going to spend the basic session on making some location maps. And that's going to take us through some very common things in GMT, such as setting region and projections and labeling axes and that sort of thing. And that's going to be used again and again throughout this course. So here are the things that you require data. Microsoft seems to not know when you're running a presentation. That's when it suggests you should update Java or install some installer. It's amazing. Can't they check? Anyway, rant over. So the basic stuff is to be able to navigate the directory tree from the terminal. So you're all familiar with the Find or Explorer window or something like that and clicking into folders, but you really need to be able to navigate from the command line. So we're going to just see how that works. There's something called redirection. So that has to do with where programs write stuff. So most Unix tools and GMT are kind of like Unix tools. They write to the standard output. Right? You don't really want that because that's the terminal. Because you're going to fly by and you have no use for that. So we got to redirect that to a file usually. We'll talk about what that is. Find out what's in your current directory from the command line. You're going to create and destroy files and directories on the command line. You want to make sure that the scripts that you build are executable programs, so you can just type the name and hit return, it will run. And then we will need at times to set some variables in C Shell and how you set them and how you use them. So that's sort of the agenda. And I'm going to go through these slides, but the slides are available, right? So you can have that for yourself. So navigate the directory tree. There's a command called cd for change directory and print working directory, pwd. That's like, where am I? You type that, you find out. So I'm going to be working in a directory today to put all my files in one place. And you should do the same thing. You don't have to follow exactly what I do and use the same names, but I'm going to make a directory. I think I'm just going to eliminate this one here to keep it a little shorter. You can do that. I'm just going to call a directory called short course, and I'm going to do all my work in that one. So I'm going to switch to the terminal. So you can have this on your browser window. So here's my terminal. Is this big enough font for everybody? You see it?
As a note, you should all follow along in the terminal instead of looking at looking at it, trying to do it yourself.
Yeah, so we're going to sort of do it together, right? So open a terminal if you don't have one. It usually will put you in a home directory, but if you're not sure, you can just say cd with nothing, return, and it will put you in your home directory, whatever that is. And to see what that is, we can type print working directory, pwd, hit return, and it will say, for me, it's /users/pwessel because it's a Mac, because everything is /users and the name of the account. If you're on Linux, it's going to say something home, maybe, I'm not sure, depends. If you're on Windows, who knows what it will say. /c/ yada, 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 something. Right. It doesn't really matter. So everybody, and now is a good time to put red stickers up right away if any of these things don't work, right? Because we need to get everybody comfortable with moving around into the directory. So I'm going to switch back to say something about making, okay, let's create directory. We're going to do it in the order we're going to do things. So I'm in my home directory. I want to create a subdirectory where all the UNAVCO short course stuff should happen. And there are a couple of commands to deal with directories and files. One is called mkdir for make directory. And then there's an rmdir for remove directory. I hardly ever use that one because it only works if there's nothing inside that directory. So usually there's stuff in my directory. And then there's rm for remove. And there's some flavors here. Usually you have to say -f to the rm command to make it really delete. Otherwise, it may ask you a question. And that's good if you do interactive stuff. If you're writing scripts that kind of run at night, you don't want the script to stop and asking you, are you sure, when you're sleeping, right? You want it to happen. That's why you typed it, right? So force. To delete directories, you also have to have a -r. So if you have a directory called figs, which is your entire dissertation tree, do rm -rf figs, it's gone, right? So you got to be sure you know what you're doing. So that's the problem with these force options. It assumes that you know what you're doing. Okay, we're going to try a mkdir here. So I'm going to go back to my terminal. I'm in my home directory. And I'm going to say mkdir, what I call it, short course, short course. That's a long, but mkdir short course. Nothing happened. To see that something happened, I do an ls, which is a list command, just lists what in directory. Because I have tons of stuff in my directory, so that may not be very helpful, but this is everything in my directory. And there is a short course folder there. And I'm going to move into that one. So I'm going to do cd and the name of the directory, short course. And if I do a typo, like short course 4, it's going to say no such file directory. So that's pretty understandable. Instead of retyping that command, I can use the up arrow on my keyboard to bring up the previous command. This saves a lot of typing. And then fixed my typo, obviously. And now cd short course. And I have my prompt set up, so it sort of tells me where I am. You may not have that. That's a configurable thing. But to make sure you're there, pwd will say that, OK, I'm in my short course directory. So that's really all there is to making a directory. If you want to navigate out of that directory, you want to go one back up, you can go one step up to the parent directory by doing cd space ... That means the directory above me, whatever that's called. In my case, that's my home directory, right? Because pwd will now put me there. So if you want to go up one directory and down another one, you do cd ... and then cd down to whatever that's called. So that's sort of the essence of moving around. There's shortcuts to all those things, and you can optimize things with aliases and a whole bunch of stuff you don't have time to do. But that's the basics. And if you're lost, pwd will tell you where you are, and then you can cd up and cd down into where you're going to be. So I'm going to go into short course again, cd short course. Also notice that if I type short and hit tab, it will autocomplete if that's unique. So you can save a lot of typing by being clever with how you name things. So if they all call very, very, very long directory 7, very, very, very long directory 8, that can be a little tedious. So keep something relatively short. Okay, I am in my directory, and we will jump back to this. So we've done this. We can go back and forth. Redirection. This is a kind of complicated thing, and we'll try to stay away from most of the redirection things. But basically, as I said, Unix, there's 3 concepts of files that you need to be aware of. There is the standard input, usually called std_in. That's where programs read from. And that usually means your keyboard. Now, it's very rare that you're actually going to be typing data into programs. But that's where Unix tools read from. So you got to change that to read from a file or something, right? So that's redirecting it. And you can see here, if you have a command and you use the left arrow and some file name, it will instead read from that file instead of you typing on the keyboard. We will probably see something like this at times in the script. I use this a lot. You're writing a GMT script and you want to plot 2 labels, maybe a name of a city and some label over here. It's just 2 lines. You could create a file with those 2 lines and worry where that file is, or you can just write it as part of the script. And it's called a here document. That's the Unix name. Meaning if you give this to the program on the command line, the program will now read from your script until it finds whatever that EOF character string is. It doesn't have to be EOF. It could be junk, or this is a very long ending, something, anything. It will keep reading until it finds that magic phrase. Then it stops reading the script as a data file. So it's very convenient. You don't have to have an extra file. You just read from the script itself. You have 1 script with the data and the commands. You'll see examples of this as we get into data. Output redirects to the right. That will send the output from the program to that file instead of printing it on the screen, which is standard output. And then the third file is standard error. It's also the terminal. So if the error messages, they will show up on the terminal. But it's actually a separate file than the outputs. And you can actually separate these into a log file and a data file. You're probably not going to do that. But that's where the 3 outputs are. And the last redirection thing is a pipe symbol. That's the vertical bar on your keyboard. If you want to run one program, it will produce some output on standard output. But if you want to send that as input to another program, you can pipe it. It's like plumbing, right? You put a pipe to this and this, and now the stuff goes from program 1 to program 2. That's very convenient. And you can have as many as you want on these things. It get complicated. We're probably going to see that in some of the examples. But that's the extent of redirection. And then we're going to do the examples, and you'll see how it works. ls, I briefly did ls to show what's in my current directory. I did ls. But you can, ls is a Unix program. It takes arguments. There's just some examples. There's a lot of ways to run ls, but ls-l will show you the directory contents, but with more detail, like size of the file, who owns the file, permissions, that sort of thing. You can give file names or wildcards to ls. Find all my scripts, ls star.sh. Star is a wildcard, means anything that matches. Here I make a file. I head the redirection, ls star.pdf. Save those in a plots.txt file. So I have all my names of my plots in this file. And here I pipe. ls-t gives me the most recent files first. Pipe it through head, gives me the top 10 files that I just created. Because I forgot what I call that one script. I just do this and I see, oh yeah, it's junk.sh. Forgot. Okay, what else do I have here? We did this already. Yes, making script executable. So I'm going through this kind of fast, but we can actually do it, right, in a minute or so. When you create a script file in the editor, it is just like a text file. A text file is not a program. You can't run this text file. But we can tell Unix that actually this script is actually going to be executable. And we have to change the permission of the file so that the system will allow you to run it as a program. And we do this with this strange Unix command, change mod. And change mod takes arguments. Here we're going to turn on the executable bit. We're going to tell it that it's going to be an executable program and the name of our script. After that, script.sh is kind of like a program. You can type it on the command line, it will run. There's 3 ways actually then to run the script. You can invoke bash directly. bash space name of the program. That will run. Or we'll see this sometimes. Give bash some options. That option will print out all the lines in your script on the terminal so you can see what's happening. Very useful for debugging when your script doesn't work and you want to see what's going wrong. You want to see which command is actually breaking your workflow. And then, of course, this one that we just talked about. And finally, very briefly, because we're not going to do this right away, is to assign variables in bash. It's basically you give it name of a variable, it should start with a letter, not a number, no space, equal, and whatever you want to assign it to. So here's some examples. Width equals 15C. Maybe I'll use $width as a variable in my script, so that if I change my mind, I only have to change this one line in the script instead of many times in the script. That's the benefit of the variables. Here's a more complicated one, right? What's the last most recent PDF file I made? Well, I know ls-t gives me the sorted list of the most recent files of all the PDF files I made. I pipe it through head, which just gives me the beginning of a file, but only the first line. And then I run this command in backticks. So that's the Unix magic. Anything in backticks is run first as a command. It's going to produce a single PDF name, and that's now assigned to a variable called last PDF. I can print that out myself. So you can do a lot of stuff in Shell. It's a programming language. This is a little bit advanced right now. That's it. If you can master these things, you can function well in GMT. And we're going to practice some of these things as we go along. Any questions about this so far? So we're going to get out of this thing here and open the GMT basics file, if I can find it. All right, GMT basics. All right, so the goals for this session is to talk a little bit about the GMT modules. You'll see there's a link there to the documentation. You may want to set a bookmark there so that you can quickly find where things are. There's two things about GMT that you'll need to at least know where to find out more about. There's the common options. So common options are options that are the same for every GMT module. So -R for region. If a program has the -R option, it's the same one as all the other programs have -R. It always means the same thing. There's a whole bunch of those. In fact, if we go to, okay, let me go down there. Common options, I clicked on that link. You'll see there's a whole bunch. These always mean the same thing everywhere in GMT. You're not going to remember all of them. You will remember a few of them after running a few GMT programs. Most of us remember a few of them. The rest we have to look up because we use them infrequently. But that's where you would learn about those options by themselves. Default settings. So GMT can be tuned to do a whole lot of things. For instance, you make a plot and you say, I don't like that font on the base frame. I want to use Times Roman bold. Why doesn't GMT use that? Well, you can change that, and why is the pen thickness this way? I want it to be thicker. Well, you can change that. So there's a whole bunch of these, like hundreds of fine-tuned parameters that you can change. And that's in the default settings. So it's good to bookmark this in the beginning, because if you need to change any of these things, and we're not going to change too many of them because there's 100 and who knows how many. We're not going to go through and talk about what they are. But if you have questions like, how about font colors? Why is it this way? It's usually some parameter that controls that kind of behavior. And you would dig into these things. And they're categorized by, is it PostScript related, or is it color, or whatever. There's different categories. None of us remember all these 180, whatever they are. We have to dig it through. But the key thing is to know that there is such a thing called GMT defaults. And if you want to change the behavior of GMT, it's probably controlled by one of those parameters. We will use some of them, but we're not going to spend too much time on those guys. All right, modern mode. Modern mode is a GMT 6 feature. GMT 6 hasn't been released. We currently have a release candidate 3. So even those of us who wrote GMT modern mode haven't used a whole lot. I mean, I've been using GMT since, God knows, 1987, right? Back in the Reagan administration. So I have 30 years of GMT classic mode and barely a little bit of modern mode. So I'm a rookie too when it comes to using it. But hopefully I know a little bit on each side. So if you used GMT before, you'll have to change how you do things a little bit for this session. Yeah. So the essence of this session is to make some location maps. That's sort of really basic stuff, putting up a coastline and see where we are. So before we actually do the first plot, a few things about mapping basics. To make a plot, we need to specify what part of the Earth do we want to make a plot of. Right? Pretty basic. You got to specify where do you want to make the map. What part of the Earth? We call that the region, data region. Let's say you want to make a plot of this little region here. You need to know where is that, coordinate-wise. And the other one is the Earth is a ball, some sort, and we're going to make a plot on a piece of paper. So there's got to be some sort of projection involved to turn the Earth spherical thing into a flat piece of paper. And that's map projections. And there's lots of map projections out there. And GMT has a bunch of the most important ones. So we have to specify that. You can't make a map without having some notion of projection. And then usually you want to put a base frame around your plot so you know where you are. You can navigate the coordinates and stuff. So those three things, this is optional. You don't have to. You can just make a plot with no frame. But most people want to put a frame. So it's optional in the sense that GMT won't tell you that you need it. But region and projection is usually, is that a question? Yes.
So why is the frame important?
Why is it important?
Yeah.
So you can tell where you are. Because let's say, here you might be able to recognize where this is. But if you zoom in a little piece here and you're not from the US, you may not know where this is. So that would be a bad.
It also gives the notion of scale.
Well, yes, right. So you can see,
you see the
Australia, this is a world map, maybe, versus I have no idea. So yeah.
Then at the scale, it's more complicated for man.
Yes.
The coordinates already give you a very good notion of the scale.
Yes, that's true. So usually we're gonna do this for these maps. You're gonna put the frame on. It's not optional in that sense. Map projections. I'm not gonna spend a lot of time telling you about map projections. You either know some already or you don't know. Just very briefly, in GMT we have kind of 4 classic categories. 3 of them are sort of very geometrically inspired. Right? We have the azimuthal projection, which you can imagine taking a flat plane and touching the Earth somewhere. If you touch the poles, it's a polar projection. If it's somewhere else, it's a general projection thing. And then imagine that you are at the center of the Earth and you draw a line through the Earth and any feature on the globe, and it's going to extend to the piece of paper, right? And then you make a little mark there. So if you trace the coastline of the Earth on the sphere, that laser beam that burns on the paper is going to be the map projection. You can also do this from the antipode of your projection, then you get a different projection. And there are many ways on that theme to make sure that the plot is equal area or conformal or some other thing. But they all have this feature in common that there's a tangent point and you project somehow onto this piece of paper. That's azimuthal projections. Conic, piece of paper, roll it up into a cone, shove the Earth into the cone. Usually the way these is described is that you actually shove it through the cone a little bit. So you can imagine the Earth cuts the cone at 2 parallels. Right? And those are parameters to the conic projection. And then it's just a question of where do you put the origin and the scale and how you project onto this piece of paper that you unroll. There's different ways to do that to get different properties like equal area, conformal, equidistant. But that's the essence of conic. And cylindrical, same thing, roll the paper around the Earth and project from the center through whatever feature onto the piece of paper and unroll the paper. Depending on how you orient the cylinder, you get Mercator, transverse Mercator, or some oblique Mercator, or other properties if you insist on equal area and conformal and so on. And then in addition to that, there is some just a class of major projections that shows the entire Earth on one piece of paper. So that has a lot of distortion, right? Because you have to unwrap this orange onto this piece of paper. But they're useful to show global data sets. So we'll do that today. Okay, so that's essence of what we're going to do. So here's a GMT modern mode script. We're going to start typing in a minute here. Before we do it, just dissect some of the features here. So all your script should start with something like this. It's a special Unix command, basically, that says so it's right here. Hash bang slash. Usually you slash user slash bash. But this is the operating system insensitive flavor. It will always find the bash shell if you run it this way. So all the GMT scripts, we do this now to make sure it runs on any system instead of most normal systems. So this says the first line of the script. It says this script is actually a bash script. It should be run with bash. By itself, we won't do that unless we change the mod, the executable. But that combination makes this a script. All GMT modern modes start with GMT begin. And they end with GMT end. Since this is completely new, you can't accidentally get an old GMT script to run into modern mode, right? Because there never was a GMT begin and end. So all classic GMT4 scripts that you may or may not have will run as classic GMT scripts, right? Because there's no begin and end. But we're going to do modern mode, so we have to start with GMT begin, do all our GMT and Unix stuff, and end with GMT end. There's some options to GMT begin. We can name the session. If you don't do it, it'll be called GMT session. Usually, you may do that to name the figure, if the script is making a figure. It's just processing data, then there's no figure. You don't have to worry about it. But if this script's going to make figure 1 in your paper, you might as well call this figure 1. And optionally, what kind of graphics format do you want? By default now, in GMT modern mode, we make PDF. You know, familiar with GMT, we made PostScript all these years, which is a tedious format that you have to convert to something else anyway. But the default is PDF, but you can specify other ones like PNG or both PNG and PDF, so on. So that's a new thing. We're going to do the GMT commands. And then GMT end, there's an optional word show. You put show there. When you run the script, it makes a figure. It will open this figure in the default viewer of your system. And so when you're doing scripting with figures, that's usually what you want. You want to see the plot right away. So that saves you having to open that figure up. All right, so that's sort of what we're going to be doing in the next few minutes. We're going to start off with making a map of Italy. But to make a map of Italy, there's a few things. We got to start a new GMT mode script in editor. We're going to use the Visual Studio Code. We got to make a decision. So where is Italy again on the Earth? Coordinates or something? Projection? Do we have to? Do we? There's some questions here. Turns out that we can get away with a bunch of stuff in GMT modern mode that we couldn't in classic mode. We'll tackle these things as we go. You know, projection, land. We're gonna plot Italy. We're gonna fill it with color in the coastline. What are we gonna do? We got to tell GMT to do something. Decide if we want the frame. How do you want the frame to look like? Do we have to? And then we're going to run the script and see if the plot worked or if we got lots of GMT errors, which will happen to most of us from time to time. And then, you know, if we didn't like it, we change the script, run it again until we're happy. So that's the plan. So we're going to do this now. So I'm going to use Visual Studio Code, which I haven't really used more than a few times. So this is what it looks like. If you're not using it and using something else, and you know what you're doing. If you're like me, you don't quite know what you're doing now, but that's what it looks like. And I'm going to do File, New File. It says Untitled, so I guess I have to name that. I'm going to save it. Save as. I know I created a short course directory, so I can try to find that. Ooh, okay. I got to go to Home Directory. Short course. There it is. Okay, what should I call this thing? I'm going to call it italy.sh. It's going to be a bash script. You can call it .bash, but I'm lazy. I call it sh. It's close to shell. And that's where my script's going to live for this session. Yes, the instructors look for the red flags because I'm blind. I'm doing my thing. So. Okay, so now I have a file called italy.sh in my short course folder. It has nothing in it because I just started. But what do I want in it? Well, I showed you a kind of a template, right? I said it should look something like this. So, okay, so this thing there, bin user bin env bash. Okay, so hash bang slash user bin env bash. You might have to look that up a few times to get it all right. That's a magic Unix incantation to say, run what follows in the bash program. Yeah. And Unix is very unforgiving. If you have any typos here, it will not work. So make sure this is exactly correct. And I hope this is correct. Just, if you see me screwing up, best not to tell me. Let me just crash and burn so you can explore the ramifications, because it will happen. I will forget to do something. OK, so that's the first line of any shell script that you're going to ever write doing GMT. OK, so what was the next thing? Something about GMT begin. GMT begin. And it said something about optional session name or figure name. Well, I know I'm going to make a figure. And I call the script italy.sh. I might as well call the plot italy.pdf or italy something, right? So I'm going to call it italy. That's my session name.
You call it 1 and 4.
1 and 4?
Yes, 4.
For your thing. OK. Well, I'm ahead of you, so you have to adjust your session to my session.
So you don't have to put it in brackets.
No bracket. Oh, yes. That's an excellent point. Why are the brackets here? OK. So as we look into the man pages, we're gonna, the documentation for all these programs, there is a established way of writing man pages. When you see things in brackets, it means the bracket should never be typed, but it means the stuff inside is optional. Okay. So you may or may not use it. And if you do it, don't put the brackets, just put whatever should go in there, name PDF, for instance, or PNG or something. And same thing with session names. You don't have to give it, but if you do, no brackets. Yeah. Yeah, that's a good point. That's how you read the man pages, because they're all going to be like that. Yes.
Like languages, it's like that would be a list.
A list?
In another coding language.
Oh, yes. Yes, that's right. Yes, yeah. Yeah, this is just the syntax of man pages, which is very terse and dates back to before the Reagan administration. OK, so I'm going to make a PDF, which is the default. I don't have to. I could do this, right? That'll be fine. Say that it's a PDF plot, but that's the default, so I'm not going to do it. OK. And then it's going to end with GMT end show. I'm going to do. So in between here is where I'm going to write my plot. Now, I like to think of this as programming, so begin and end, and I should indent everything by a tab. That's just how I do things. I'm going to do this here, but you don't have to. But I like to see where the begin and end is. OK, so we're going to make a plot of coastlines. OK, then you need to know what's the module to make coastline plots. And it's called coast. If you didn't know, how would you find out? Well, you would have to read the introduction to GMT, look at the examples and stuff. You shouldn't necessarily know this already, right? So we're going to skip that step of reading the introduction and see the capability of GMT, and just assume that we understand coast is the command that we need to run. GMT coast. So every GMT command has to start with the word GMT space and then the module. Otherwise, in modern mode, a huge big red flag will come up and say, hey, you got to start with GMT. Yeah.
Would you look that command up in the module?
Yes, we can do that right now, because I don't remember any of these things. So I got to go and find, where's my man pages? Use the terminal. Thank you, Leo. Yes, he knows more. So, OK, so this is a classic example. How do you run the coast command? What are the options? I don't remember. I could go to the documentation online and click my way through, or I can use the GMT docs module. So I'm going to say GMT on the command line now. This is the time when you run things on command line, despite what I said earlier. GMT docs coast. I want to learn about that command. And it opens the browser at the documentation. That's faster than finding the link and clicking your way through stuff. All right, so now we have a man page. What the hell is that? Well, it looks like this. Is that too small for you can see? Command plus?
You have to really build your screen.
Yeah, that's true. But since it's projecting up, I should do that. Okay, so man pages written by Unix geeks in the 70s, I assume, who decided how they should be written, and they should be terse and unintelligible to most users. So this is a synopsis of what the GMT coast command can take, and everything in brackets again is optional, and things that are not in brackets are required. So we can see here then that minus J, what is minus J? Well, it's a GMT common option. If you want to learn a lot more about it, you can go to the common option listing that I showed earlier and see, oh, it's projections. It has all the projections. It's not a simple command. It's 27, 28 projections with parameters that are all different. So that's complicated. We're just going to stay away from the details of that, but that's where you will go to explore other projections. Region, yeah, we got to say where we're going to make the plot of. There is no default. Maybe there should be a default of the world. I don't know, but there is no default. And then the rest is all kinds of esoteric options for specifying pen of the coastline, the filling color, scale bars, turn off small features, all kinds of stuff that we're going to not spend too much time on. But apart from the synopsis, this one description tells you what it does, what it's capable of doing. It should be more or less correct. It's not always correct, but it talks about painting land masses and drawing outlines and so on. Political borders, rivers, they can also plot. Can plot cities. There's no city database. If you want to plot cities and labels, there are other ways to do that, but not through this tool. And then there is explanation for minus J. Click here to see more. Region, how to specify region. There's a lot of ways to specify regions. This is intimidating to read, right? So we're not going to really read it, but you can see it will talk about everything. But what I'm going to focus on that you can actually use country codes if you're going to make plots of countries or continents or something like that. And that saves you from knowing where the hell is Italy. You may not know. And you have to have a map to look up where it is. And if you have to have a map, how do you get the map? You have to plot it in GMT. So how do you plot it? Well, you need to know where it is. It's a vicious cycle. So we're going to use Italy. So it's 2-character ISO code, which is IT for Italy. And try that. So you're going to go back to our script. Coast, it's minus R is the region command. It's one of those commands. I'm going to say, well, Italy. Hmm? Yeah, it has to be the ISO 2-character country code.
So if you wanna find out what the country code is for a different country, Google Wikipedia ISO countries.
Yeah.
And it'll show a list of all countries and the code.
Yeah.
Or -C+L or something like that.
Yeah. So it is standard ISO code for countries. So US is US, Norway is NO, Portugal is PT, that kind of thing. You can guess it pretty well. What do we do with coast? Well, coast can draw lines or plot pen. So how do you draw an outline? Well, you have to read what it can do, and it's all these options. Instead of reading all of them to you, I got look at these painful ones. I'm going to go down to the bottom for W, because usually pen is a W. And it says, draw the coastlines. Default is no shorelines. Append. Default is a solid black line. Okay. I'm going to draw a pen. Minus W. Joachim's going to tell us about pens later, I think, in detail. But for now, I'm just going to say, how about thin? Thin pen. I don't want a thick pen. I said projections are required. Well, in GMT modern mode, actually, there is a default projection if you don't specify it. So this is actually the most bare bone coastline script we can do. You don't need a J. You probably want the J, because you probably want to control what that is. But if you don't specify one will be chosen for you. Okay, so I'm going to save this script then, right? Save. Okay. I don't see any obvious typos. No? Okay. All right, so now what I do? Well, I'm going to make it executable. No frame. No frame. Well, that's okay. We can add a frame later. Okay, so everybody happy with this script? Okay, I'm going to go to the terminal and do ls, like the pwd. Oh, I'm in short course. Okay, ls. That's my script. ls minus l gives me a longer listing of the script with the date and who owns it and size and stuff like that. It's 75 bytes. It's not a pretty small file. And there's all this magic stuff up front with RWRR. That gets the file permissions. And it says that I have read and write permission, but people in the group and others can only read. It's not a program. It's not executable. So I have to run that strange command, change mod plus x I tab. It'll run. Do an ls minus l again. Now it says rwx, rx. It's not an executable program. That's what we have to do to make the script a program. Doesn't look any different in the editor, right? It's just a text file, but now it has the special property that when I write it as the file name, it will execute. So I'm going to try that. I'm going to say it's tab. It's going to put the command there. And now when I hit return, one or two things will happen. In my case, it will run the Italy script, and hopefully it will work fine. It is a small chance that some of you have path set up that doesn't include your current directory. And then it will say, can't find italy.sh. So those are the two possible outcomes, I think. And maybe the other ones. Maybe there's a typo in your script. So then there's a third outcome, some strange GPT error. But I'm going to take my chances, roll the dice here, and hit. Hey, OK. So in my case, it made a map of Italy. I recognize the booth there, Sardinia, Corsica. So we got the right ISO code. It is plotting. It put up a PDF. And now it's time for the red stickers and the instructors spring into action to help people. And so let's see what's the first impression. What kind of error came up or what happened? Command not found. OK. So if your command is not found, that means that your path doesn't always include where you are right now. And then you can do this. You can say dot, which is a short for current directory, slash, and then Italy.
Yeah. Almost everyone's going to have to do that.
Yeah. And then it should run. Yeah, OK. So during the break, we can tell you the secret of having the current directory being part of your path, which is very handy.
In the old days, now it's security.
Yes. Yes. OK. So did that solve everybody's red sticker? Good.
You could even add that to your path.
Yes, exactly. So we'll do that in the break because we got to edit everybody's. Yeah. OK. So everybody got a plot? More or less? More or less? Lauren? No? What happened? Are you in that directory? Slash. Is file not found if it's there? OK. OK, so we got no frame. We just got the box. It's clearly a projection was selected. It turned out to be a equidistant projection that is just scaling long map the same way. So not really a good map projection for scientific maps, but it puts a plot up so you can see that you're on the right track. So we're going to go back and edit our script to do something different. First, I'd like to put the frame on. Right? So we know where Italy is, but if this was some crazy country, we wouldn't know where we were. So how do you put frame on? Well, again, you kind of have to read the GMT documentation about what was the option for drawing frames. And you will learn that it's -b for border. Right. If you look at the man page for -b, it is very frightening. Don't do it. At least not yet. You can do it later, right? But not while we're here because we don't want to frighten people. But -b like that. Why do I get this? OK. -b gives you the default. it will figure it out for you and give you nice annotations. And that's usually good enough. If you say, I want more annotations or less, you may have to tell it to do that. But most of the time, I'm happy with -b. I'm going to save this.
Okay, so didn't have any error, which is a warning saying expect values from 6 to 6 or 7 to 6. It didn't work.
It worked? Expect values from 6 to 6?
Those are.
If it worked, it worked. We'll have to delve into that ugliness in the break. Okay, so I added -b. Oh.
Is there a way to put comments in
Yes, excellent point. Comments. So you're writing a script and it's the first time or it's the last time, or you want to tell yourself what you did and why you did it. 3 months later, you can't remember any of these things. So, you know, making anything that starts with a hash character is a comment. You can write whatever after that, and as many as you want and anywhere. So make our first GMT map of Italy, of all places. Polish. Okay, my terminal is small. I got to drag this window a little bit so I get more real estate. Place, I can't spell place. Okay. So yeah, so you can write anything in comments, and I encourage you to do that if you do something that's non-trivial. Because believe me, what is obvious to you right now will sort of vanish after a little time, and you can't remember it. And you spend a lot of time figuring things out. The other thing, yeah. After the commands, yes. So the hash character turns off shell interpretation. So you can put like here. I could put. I think this should work. Yeah. Starting our new GMT modern mode session. That should be fine. You can see the editor stratting. I'm not sure what that is. Star. So the Visual Studio Code knows that we're doing bash. It knows the syntax and it changes the comments to green and all that stuff. So that you know you're doing the right thing. Okay, say.
So for the online participants, they can't hear the questions.
Oh, actually repeat the question.
Yeah, repeat the question.
Yes. Yes. So we're discussing, so you guys online, if you can see the screen, you can probably see what we're doing. But if you want to add comments to yourself to remind you what you're doing or explain something, you can start with the hash character and write whatever. And that's a comment. And it's a good thing to do. The other good reason for doing this is that when you have thousands of GMT scripts and you're trying to find the one that made a plot of Italy in your computer, it can take a while. It turns out there's good find commands that can search the contents of scripts and look for keywords like Italy. So if you write something sensible in the script, it's easier to find it later when you have, like me, thousands of scripts somewhere in some folder, and I just vaguely remember I made one with an Italy map, and I can't remember where it is, what it's called. Right? And I can find it. So that's the other reason for putting good comments. Okay, I saved my script, and I want to run it again. So either /Italy, I guess in my case just Italy. And now I have a border. If you don't like the border, well, you have to look into the specifics. Why is it this thick? I want it thinner. Or why is it, the font, all that stuff. That's GMT default settings. If you don't like it, read the documentation on the defaults and change it. Like, why do you have labels everywhere? I just want the left and the south. Yes, we'll probably get to that, but there's all kinds of questions brought up here. Why is there not a north here, right? Well, it could be. It's just not the default. Okay, so I can't tell where Italy starts and stops because it's just part of Europe, and I want to isolate where Italy is. So I want to add national boundaries to this thing. So I would have to go to the coast program and look through, is there anything about national borders? And and border pen, draw political borders. You need to specify what kind of border and what kind of pen, separated by a slash. And I guess the pen is optional. It will give you a default pen if you don't do it. So yeah.
If you're like in a plane or something and you are playing with GMT, can you download the HTML documentation, or you need to have internet connectivity?
If you install the documentations, the question was, thank you, Leo. The question was, if you're on a plane and you don't have internet connection, Can you get access to the documentation? Depends on the installation. I think the installers come with the documentation. That should be correct.
Not all.
Not all. So you may have to plan ahead to make sure you install the documentation. You can buy Wi-Fi on the plane, though, which works very poorly from Hawaii. Yeah, we're always flying from Hawaii, and there's never Wi-Fi connection to purchase. Yes, so that's a good point. You would have to make sure you install the documentation. If you like, we all build from source, so we always get everything. But the installers, the Windows installers, should have the documentation, right? I think. Looking left. Yeah.
Do these parameters have to be written in the
No, the order is random. Yeah, you can do any order you want. So the question was, the command line option, do they have to follow a certain order, R before R, J, and so on? No, it's any order you want to do them, whatever makes sense to you. Okay, so we said border. Yeah, what do we say here? There's different kinds of borders, and this is not a complete implementation of every border everywhere, but we have national borders, and there's some state borders among, I think it's 8 large countries. And then it breaks down to marine boundaries, and that's it. So we're going to do national borders. That's 1. So minus N1 and then a pen optionally. So I'm going to go in here somewhere and say minus N1 for national borders, and then the slash for a pen, because I want a thick pen, and I want to make it red. So thick, comma, red. Make a red thick pen.
Can you put these on different lines?
You can, but then you have to tell the script that you're not really hitting return. So you have to put a backslash like that and hit return immediately afterwards, not a space, immediately afterwards.
Okay.
Now the bash will see that as the same line.
Okay.
So if you have some gigantic long line, you can break it up that way. I usually buy a wider monitor.
Okay.
So I have a 50-inch TV. So I never hit. We have, Joachim and I have a problem with this. I like 500 character wide lines. Okay, so you can do that, but one benefit with the modern mode is that the lines are shorter. There's less stuff to repeat. So you shouldn't have to do it very often. Okay, I'm going to save this and run it. Again, same, just italy.sh. And now I get national borders. And I bring this up so you can see that the region that we specify with IT in Italy is an exact region for Italy. Right? So this is the extent in west, east, north, south of Italy. Right? This is the easternmost point. It's presumably a tiny little island down here that Italy claims. I don't know, up there in western Italy and then north. Right? So that's a tight box. Most of the time, that will give you some decimal points on the annotations, or it will be just an ugly border. So if you want to round it to the nearest whole degree or 2 degrees or something like that, I usually do this. I'm going to go to the nearest 1 degree. I'll have to modify my -R command to say, well, I want Italy, but let's go to the next full degree. That's a modifier. Modifiers have a plus and a lowercase letter usually. And how do you want to round it off? I want to round it off in multiples of 1 degree. If I wanted 5 degrees, I put 5. And then the border will be, the domain will be in multiples of 5. Here will be multiples of 1. And, oops, that's the wrong window. There we go. And you can see the domain got a little bit bigger, right? We're not like touching this point anymore. We're going to the full degrees. So if you're making maps that involve countries, 1 or more countries, and this is a quick way to know what the coordinates are. Now that we have a map, you can see that, well, I could have done the same thing with going from 6 to, I guess, 19 in longitude. And I guess 35 to 48. Could have done that. So I'm going to do that. Now, since I don't want to lose my old command, I'm going to make a copy of that line, and I'm going to comment out the one that I ran. I usually do this a lot. don't want to delete the old command and override because maybe I was mostly right. So I have a copy there. I'm going to change this Italy business to, what did I say, 6 to, I'm going to go from 5 to 20 and 35 to 50. As west, east, or x min, x max, y min, y max. That's another way to specify the region. There's a lot of ways, but these two are the most used ones, I think. West, east, south, north, and country code. You can have several country codes separated by comma. So if you want to make a map of France and Italy, you can say FR, comma, IT, and it will double up. Yeah, so think min, max, min, max. So west, east, south, north. Okay, I'm going to save and run that command too. And it gives me the new region. Anyway, so that's how you would mess with things. And that's the default projection. Now, as good scientists, the only projection we all use all the time is Mercator. It's the only projection that science has used ever. If you look at JGR and look through maps figures, there's a lot of Mercator projections. Because A, it's very simple, takes very few parameters, and everybody else is doing it, so it must be the right thing to do. It's okay for most things, but we shouldn't do it for like Greenland and large global maps because it's huge distortion. But it is very simple. So I can actually switch to a Mercator projection. I'll leave that plot there. It's going to be overwritten. So now we didn't specify projection. We got something. What projection was?
What projection did it pick?
Well, probably
Only -VL.
minus VL or something like that. Yeah, this, you can probably, if you really want to know exactly what was that projection, you would have to tell it to give you more information back out. There's a -V verbose setting that you can specify to how much you want to know what's happening under the hood. The default is nothing, unless there's an error. It will be error. But -V will give you warnings if you do something that's questionable. And then there's a several level of intensity of warnings of messages. And you can ramp it all the way up to debug and you get every possible things that we developers need to look at from time to time. But most of the time, we don't put any V on. Oh yeah, projection. So I'm gonna do -J then. And again, we're not gonna read the whole man page of projections. It's terrifying stuff. But you know, they're all pretty simple and their GIMP documentation has examples of working projection plots for every projection. So most of us learn by example. We find something that works and we modify it. But Mercator is very simple. It's capital M. And then how wide do you want the plot to be? The height is depending on the region and the projection. But you can specify, I want a 15 centimeter wide plot. And that's what you're going to get. And that's from beginning to end, not counting the annotations and stuff. So now we're going to get a Mercator map if I run this thing. And this plot's going to go from being a little squashed this way, right, the long lat space, to be a little bit more stretchy, I think. So running Italy. Yeah, so now you can see it changed the lay of the land here. So now it's much taller. Things look a little bit more normal. And yeah, we're doing good with that. Any questions so far?
So at this point, the whole script is not truncated to limit it to some page size?
Okay, so in GMT 6 modern mode, there is no visible PostScript anymore. You have a paper size that is, I believe, 10 by 10 meters. And you plot, and then we crop down to whatever you actually ask for. So if you want to make a 4 by 4 meter canvas plot, you just specify 4 meter wide plot. So for instance, if I tried this thing here now and said, I want this to be, what should we do? 250 centimeter. Please don't crash, please don't crash. So now I have it looks weird. It didn't quite work. Why can't I make a 250 meter plot? Oh, maybe this. Yeah, you can. Oh, yeah. It is there. So we got to zoom in. Oh, there's the annotations, because now we have a 2.5 meter plots, and these annotations is font size 12 or something, so they're tiny. But yeah, there's 10 meters is the max. and it's all auto cropped for you. So, but that was, we don't want that large.
My
But-
plot, I have the characters in the bottom. They crop too much.
For this one?
For Italy.
Oh, the other one, for the what, 15 centimeter one?
Yeah, no, yeah.
And when you scroll up, it's,
Mine got cropped off.
it could be a GoScript problem. We had a lot of GoScript bugs.
Yeah, can I change the order?
Yeah, look at that.
They're getting numbers problem.
Yeah,
Yeah.
GoScript. I'm betting. See what version of GoScript he has. Yeah, so if your plot doesn't look the same as me, like being cropped and stuff, it's very likely a bug in GoScript. We had lots of bugs in GoScript. They keep reporting to them, they keep fixing. I think 9.27 has most of those bugs fixed. If you're 9.26, there's definitely problems. If you're earlier, it might be okay. So it's a moving project. We can't do anything about it. I mean, it's GoScript. We can all report the bugs. So yeah, that could be some minor blemishes. Okay, I want to show a few other things here with Italy. Tired of looking at this line. It's just the outline. I want to paint it. Okay, so if I want to fill the continents with color, the man page will say, if you look through it, at -G is the command, the option that lets you paint land, right? And then you have to specify a color. And I'm gonna just do beige, I think, as a kind of brownish, good country color. If you don't like beige, you can choose whatever color you want. You can make it pink or purple or dark blue or anything like that. Any name of a color you can probably think of. You can do RGB numbers. If you speak RGB, so how much red, how much green, how much blue flashlights to mix, you can do that. But or you can bring the cheat sheet that has all the colors plotted out and you see the code. But I find myself most of the time just picking a name of a color unless I need something super specific. So like beige is, is good enough as any color right now. If you have a typo or give a non-existent color, GMT will tell you that I don't know what you're talking about. But there's 600 names in the X11 color table, like dark salmon pink and stuff like that. You have to look at the table to know all these names. Yes. But okay, here's my beige. Oh, it shows up a little bit. It looks like greenish, right? Yeah, that's good. Where is that, Leo? Oh, it's down the bottom.
So data processing replace
Yeah. Scripps. Oh. Oh yeah. Okay. Empty colors. And it's blocked. Oh, okay.
So it has like all the.
Okay. So in the GMT man page, there's under scripts. I'll go back to this. If you're at the GMT documentation page with all the listing, there is you got to dig through this processing man pages. On the bottom here, there's scripts, one called GMT colors. And it talks about all the colors like Ghost White, Blanched Almond, Peach Puff, right? These are all the known names. And the three numbers are red, green, blue colors. So you can use R/G/B or the name of a color. And you can make up your own combination. But it's usually hard for you, most people, to come up with, I want chocolate. What is that, RGB? That's hard. Typing chocolate words, yeah. I went to the documentation, GMT documentation, which is the top landing page for GMT documentation. So docs.genericmappingtools.org is the web page. And it lists all the tools, and there's one called Scripps GMT Colors. So I got beige. Okay. How are we doing? Everybody got something up, more or less? Okay. So I'm gonna say I like this map, but I want to also paint the ocean. How do I paint the ocean? Well, what was our command again? GMT docs coast, right? Oh, that's slow. You got to read through all these things. And it turns out that -S, fill the wet areas with a color. -S and a color. Okay, so I'm going to say -S azure, which is a light blue color. It's pleasing to my eyes. But again, you can pick any color you want. The plot, okay.
Okay, this one is your script is
9.27.
Oh, there goes the theory. Because they both have 27 and it's fairly
Oh, 9.26 on this laptop. I have not, but there's two. There's 9.27 and then
people that have 9.27. Maybe that's just figuring it out.
We can do
You
that
see that it is
yeah. Let's do it in a break.
here,
Yeah.
and there's a little margin over.
Yeah, we'll do that in the break.
It's not correct.
Do it in the break. It's not 27. It's the first version of 27. The latest one that came out a week or two ago fixes this problem. So that's how it goes. Okay, so I'm doing azure, so I'm giving it land color and ocean color, and I'm going to run my little script again. And now I have a decent plot of Italy. Okay. So we are 6:12. So we have 40 minutes till lunch. So it goes. Okay, so any question about Italy? The scripts, not the country.
Could I have a better
more detail? Right, so we didn't even specify any of those things, right? It just, the question was, thank you, Leo. The question was, what if I want even better coastline? You know, I want higher resolution. So there's two answers to that one. Right now, in modern mode, if you don't specify what resolution you want, you get what GMT determines to be a reasonable resolution for the scale of the plot. You can overwrite that with saying, I want a particular resolution. So if we go to the coastline man page again, and you dig around, you'll find that -D specifies the resolution. And there's 5 resolutions from crude, low, intermediate, high, and full. So full is obviously the full coastline database. That is probably not what was selected by default because we're showing, you know, half of Europe or something like that. But if I want to say, I want full, darn it, I just add somewhere in here -DF. And now I get the full resolution, which is the highest that GMT has. And I run it again, and it's going to, well, it's pretty quick. That is the full. How can I tell the difference? Well, I can't really. I have to zoom in probably, and you can see my thin pen is starting to get a little thick. So I had to change the pen size. But that is actually getting the full resolution. I just look a little crappy because of the pen thickness that I chose. But most of the time, it works.
But guessing what is then, we can guess one better than that.
Oh, better than that.
It's not that good.
Yeah.
You want better than that.
If you want even better coastline what GMT offers, then you can Google for database for, so this comes up, you're making a plot of a smaller area, and the inaccuracies in this global data set starting to show up, like coastline is off by kilometer, which might be a lot if you're zooming in on a small area. I suggest you Google for a better data set in that region. You can plot it. We'll show how you plot lines later. Right? But this data set is from the 70s and 80s, and it's reasonable at regional to full scale, but it's going to break down if you're zooming in on, you know, a small island or something like that. It's just not going to be Google Earth quality data. Okay, so no question on Italy. What? a new line in, how I made a new line? Just hit return. Oh, new, breaking the thing. Oh yeah, backslash, return right away. No tab, space afterwards. But what the backslash means is that ignore the next character, which happens to be my return. So it doesn't see it, and it just looks like it's a long yeah. Okay, I think we're done with Italy. We should move on to something more interesting in Italy. So I'm going to start a new script. Let's see my cheat sheets here. Well, actually, there was one more thing. So I have to make some choices of what I'm going to show you in my little time left, right? So I want to show you a few things in GMT modern mode that is new and useful. So I'm going to actually bring up my Italy script. Open recent. You can't find it.
No, if you open the
It didn't for me. It didn't list it. Okay, here's my recent map. Where's my plot? My plot went away. I'll run it again. Let's say that I'm kind of unfamiliar with Italy. I don't really know where it is. This is not helping. I want to have a little insert up in the top of my plot here that shows the globe where Italy actually is, because I really don't know. This is kind of silly for this case, but you can imagine you zooming in on a piece of real estate that you're familiar with, but no one else knows where this really is. So it's usually good to have a little location map that indicates you're actually here. In GMT's modern mode, we have a new module called Insets that makes, basically it specifies where do you want the inset to go, and you can plot another map there, and it will fit in that box. And when you're done with it, you turn inset off, and it goes back to this map, and you can add more things to it. In GMT Classic mode, you have to sort of manually do all those things. You got to move up to the corner, you got to change the scale, you got to remember to unchange the scale. It's kind of more intimidating. So with this one here, we got to type GMT docs inset. Manage figure inset setup and completion. You can read this whole page, but you don't have time to read the whole page. But basically, you specify where's the box going to go. Possibly you want to paint the box with some color and a line, an outline. And maybe there should be some margins inside the box so that you don't draw exactly up to the box. And then you make another plot, basically, but it's going to appear in this little window until you say GMT inset end, and then it's undoing that. We're going to try this. We're going to go back and forth this map page. But after I make my plot here, I'm going to say GMT. Oh, I can't control that one tab. I'm going to undo this break line here. I don't like broken lines. They're unnatural. Should just get a bigger turbo. Okay, GMT. Microsoft won't let me have one tab. Why can't I have one tab? I have to delete it like that.
Look at the bottom. Your spaces are 8.
No, but it did 2.
Yeah, 8 and the other.
I gotta ignore it. Okay, GMT inset begin. And I gotta specify my box with -D. There's a couple of ways to do this, but basically, where do you want the box? And what's the size of the box? And I'm going to do the following shortcut. I'm going to use the justification way of specifying it, which means I can specify, if I look at my map again here, there are 9 points on this map that I can specify with a keyword. And that is the bottom left, bottom middle, bottom right, center middle, center, center, and center right, and top left, top center, and top right. Those 9. And if I use those combinations of top, bottom, center, middle, all that stuff, I can specify any of those points as a reference marker. So I'm going to use the top right. So DJ, top right, that's where my box should go. How wide should the box be, or how big should the box be? That's with a modifier +W. And I'm going to try 4 centimeter. And we'll start with that. And now I'm going to make a little global map. Fit in that little I'm going to make a globe 4x4 in there. So that's going to be GMT coast. The region of the world. Okay, so we have a shortcut for that called G for global. So minus RG means the entire. I need a projection. I want a projection that shows the whole Earth as viewed from infinity, kind of over Italy. So since we're running short on time, if you dig through the documentation, you'll find that the perspective, what's called G, I can't remember the name of it now. It's an azimuthal projection centered on you take the plane, you touch Italy. We know Italy is somewhere in the longitude 10 and latitude 40-ish. Close enough for government work. That's where Italy is. I'm going to touch the plane there, and I'm going to say this should be 4 centimeter wide circle, and I will do beige color. I'll draw the outline of the frame, and I'm going to draw grid lines only. And so that's going to be my plot up in the top corner. And then I'm going to say, well, that was the end of the, how is doing that? GMT inset end. BG, no. Uppercase B, yeah. What's this beige? Minus BG. I didn't mean to that, but it was changing it into begin because it's trying to out-clever me. I missed that. I lost it. Okay. Hopefully I didn't do too many typos here. Start at inset up in the top right corner, 4x4. There's going to be a 4x4 box tucked up in the top right corner. And now when I plot, that's where the plotting is going to happen. It's my job to not make a 5-meter plot up there because it's not going to fit. But I'm making it 4 centimeters because that's what I specified. And I'm doing a certain projection, perspective projection there. And we'll see if this works here. If I can do 2 things at the same time here. A script there, and my monitor terminal up there. It doesn't look at that. Oh, that sucks. So, what the? Huh? Oh, yeah, okay. So we didn't paint the box itself, so the background is the same map. Okay, that's one thing. I said 4 centimeters, but this thing is sticking outside. Why is it sticking outside? It's a little tricky, but if we go at the, when you look at this map page, it says there's a margin, and the default for the margin is non-zero, meaning it has the box, and then there's a little margin inside, and that's where it's plotting. And we ignore that, so now it's no longer 4 centimeters, right? Because we lost the margin. So I'm going to turn off the margin. I don't want them in margin. We don't want that stinking margin. So margin is minus m apparently, and I'm going to say I'm going to have 0 margin. It's stupid to have a margin. We're just going to have a little inset figure. So okay, that should turn that off. I'm going to run it again. Much better. Oh, we forgot to paint the background. Yeah, okay, so there's that. But now we have it up in the corner there. We need to paint the background, otherwise the beige on the beige, we can't see anything. Okay. Red sticker. Okay, so the reason we don't see squat here is that it's overlapping on the other beige, so everything is beige, we can't see anything. So we got to paint the box. Okay. How do we paint the box? We got to look at the documentation for this. Here's the margin, by the way. 0.5 centimeter default, so we lost a full centimeter, and that's why it got off there. Draw minus F. Draw a box, and we can draw the line, we can shade it, and we can do all kinds of stuff. That's what the modifiers are. but minus f plus lowercase g and the color should be the basics. Everything in brackets are optional, right? So there's a lot of stuff that we're not going to worry about. We're going to introduce them one at a time. So minus capital F and lowercase plus g, I guess white. Draw a white box behind.
I need a comma there. Put a comma in that.
Comma. No comma.
Okay.
So plus g is the modifier, and then it takes the color. Comma would cause trouble, I think. Okay. So now I have a white box. I think I should draw the outline of the box. So I'm going to draw the outline of the box. And also, you know, it looks kind of stupid being tucked all the way in the corner. It would be nice if it was slightly offset from the corner. So I'm going to do two things. I'm going to draw the outline of the box, and I'm going to move it, you know, 0.2 centimeters away from the corner. Okay. Draw the outline. Well, the minus F scary message says one option is to put modifier plus P for pen, and I'm going to give it, you know, thick pen. Plus P thick. And the other thing was this offsetting the top corner. So how do I do that? Well, this minus D option has somewhere down at the end here, optional plus O offset by dx and dy. So that's going to take it where it is and shift it away from that corner by that amount, plus O. So I'm going to add to the minus D here, one more modifier, plus O, 0.2 centimeter. And if I don't give slash for y, it'll be the same for x and y. So this is going to move 0.2 centimeter away from the corner. And we're now drawing the box. Why is this thing up? Okay, so now it's starting to look better. Move the box away from the corner by 2.2 centimeters. And we're drawing the box outline. And now we can see the world. Where's Italy? Can't see Italy at all. So that's not really helping. So we should color Italy differently. That'll be the way to do it. So I'm going to use red, which is kind of bright color, and paint Italy red on top of this map. How do you do that? Well, you would have to go to the Coast man page and spend some quality time looking at the options, right? It's like, because you don't know. And the first time, you just don't know these things. It's quite normal. But you will find minus E option at some point that says E, code 1, code 2. These are ISO codes that we'll explain. And there's a plus G fill and a plus P pen that goes with that. So you can specify one or many countries that should be filled with whatever colors and pens that you want. So I'm going to just do Italy in red. That's going to be minus capital E, it, plus lowercase g, red. And that should paint Italy in red on top of my little insert. So that's down here in my coastline, minus E, it, plus G, red. So it looks like gibberish, right? But you have to recognize these modifier plus things. Geodesy 7, I hear, will have long options. Is that correct? Yes. So Geodesy 7 will have full words for these things. English. Yes. Okay. So if you believe what I typed there, we should get the little Italy up. There it is. Okay. So we can actually even see it. We squint a little bit. There's a tiny country. All that pizza. It's amazing. Yeah, it's in Brazil. Yeah, that's right. The Greenland and Mercator. Oh, really. Okay, so that's a pleasing figure. It's not bad. It's not too much dark magic. If you look at the script here, we just set up a session. We made the plot. We spent some time changing the option until we got something we liked. It's pretty common. We all do this, right? And we'll see when we get into things like plotting color images from grids and stuff, and Leah will talk about that later. Start with a low resolution thing. So map comes up quickly. Because first you got to find where you're going to plot and be happy with the colors and things. And when you're happy with those things, you can get the high resolution data that takes longer to plot. So don't waste 2 minutes for a bad plot to come up. But here, it thinks it's pretty quick, coastlines. So we messed with that until we got it where we wanted, and then we tried this new inset command, which it's not too bad. It just moves you somewhere on the page and sets, I'm going to plot in this little window. And then you can plot whatever you want there. It doesn't have to be a coastline. It could be anything. And it will go there until you say GMT inset end. And then it goes back to where it was. And we could, after this inset, we could continue plot symbols and lines and whatever on our idly plot. But it's probably best to let the inset be the last command in your stack, so it overprints everything else. Yeah.
So what exactly is the difference between you typing in a GMT inset inline
Yeah.
and GMT coastline?
Here? So
Like which commands go where?
yeah, so this one here, it basically says, okay, from now on, I'm going to start a mini plot inside my current plot. It's like a begin statement. We're going to switch into a different mode that's just going to look at this little inset. So that's why this one comes first. Here, between an end turns that off, basically. So that's like a begin end, just like GMT session begin end starts the session. This one starts the inset session. Inside here, you can do whatever you want. I just happened to pick another coast plot because I wanted to show the Earth there. But it's up to you to do whatever you want to do in that little window. And any plotting that you do will only show up in the inset that you've made for yourself. If you, and maybe we will fix this in GMT 6.1 or something, I had to specify 4 centimeters here to match my 4 centimeter here. Maybe we should figure out a way to not have to do that. We should know these things because we already said it, but we haven't done that. So right now you're in charge of making sure your plot in the little window fits in the little window. And as you saw in the beginning, mine didn't because I had a margin I hadn't thought about. It went outside. Yeah.
So you're plotting somewhere like on the other side of the globe.
Yes.
Automatically, if your globe image automatically goes to the other side based on
No, right now it doesn't. I mean, right now the key is right here. So I'm taking this piece of paper and it's touching the Earth at that point. So if you want to do this for Taiwan, you would have to change this to 120 and 32 or something like that, wherever Taiwan is. Right? That's the long lat of the point of contact. That's the center of the map. That'll be on you. It doesn't flip that around. Yeah. Any other questions on this one? So this is a useful kind of script for figure 1 in your thesis or a paper. You set the state where you're working. Here it is. It's pretty common to see those kinds of plots. And so now you have a template for that. Basically, you can mess around with the regions and all that stuff. One more thing, last time I'm going to run the script is to say, well, I want PDF, which is the default. I also want a PNG, because my journal wants me to send a PNG in for some reason. Okay. And if you also wanted a JPEG, you just add another comma and JPEG. So you specify how many kind of flavors do you want. Actually, I don't really want a PDF. I just want my PNG. I'll leave that one there as the PDF. And when I run my script now, it's gonna, GMT makes PostScript plots. Since the beginning of time, it's been making PostScript plots. The big change in modern mode is that you never see the PostScript plot, which means you can't screw up and putting things in the wrong order or anything like that. That's all hidden from you now. And so at the end, when GMT end comes, it will put together a PostScript file and convert it to something sensible like PDF or PNG or something. Yeah?
So when you have PDF, PNG, like all of those, when you run it, it's still
Well, we can find out. So the question was, if I give it a whole bunch of graphic formats like PDF, comma, PNG, and I have show on, what happens? We'll find out. My guess is that for some system, it's a different application. I may open PDF and PNG, so you make two different applications coming up. Oh, I got two things. Oh, look at that. So because they're different kind of animals, I got a preview in the Mac open up two separate windows for me. And this is the PNG. And if I zoom in on that one, it should start to get pixely, right? because it's a raster. You can see it's starting to get a little fuzzy in the edges there. But the PDF, well, never mind the pen looking a little crappy. It doesn't get pixely, right? Because it's no pixels there. It's just all vector graphics. Yeah, so I'd stick with PDF unless someone forces you to make something else, or you're putting stuff on the web page. Yeah. Another what? Oh, insert. Another command? Another country? Or color it? Oh, well, you already set up that you can't show the other side, but we add, let's say we want Germany, what is Germany? For South America? Oh, center of the plot. Yeah. Oh, this one here, we could go to Peru, which is probably guessing 70 west and 15 south. Is that getting closer to Peru? It's not going to show Italy anymore, but we will run it and we'll take our chances. Yeah, so now this one out there, and it's like, where am I? But yeah, that's where that goes. Great. Okay, we have 50 minutes to show you something more complicated. So, okay, any questions about Italy? We covered a lot of ground actually with just getting modern mode operational. Yes. So if you want like a map scale to say what's the distances and stuff, you need to look into the -L option in Coast and see what that requires. And that will put a map scale on the plot. And it takes some options to make it work. But yeah, it's complicated, so I don't want to do it. Yeah.
Can we specify the resolution?
Yes. Yeah. If you want to change the dot per inch on these things, there's a setting. You have to look at PS. Actually, you have to look at. You got to look up where that is. But it's a parameter. The default is 300 dots per inch, but you can change that to something else. Yes. Okay. We're done with Italy now? We're truly done with Italy? Okay. Let's see. We have 15 minutes, so let's see what is a useful thing to do in 15 minutes. We're going to start a new script. I'm going to call it world. I'm going to save a brand new file as world.sh. And since it's good practice to write these things down until they sit in your bone marrow, what's the shirt say again? Hash, I can't read my own shirt, bang, slash, user n, bin n, if you're gonna do, it doesn't say that. I got the wrong shirt. Okay, something like that. I think that's what we did earlier. That the shirt is outdated. We used to do this, and then we learned that some Linux flavors don't understand this. It's like crazy. GMT begin, GMT end. So, right, that's where we were before, I think, when we started the day. Okay, I want to do a couple of world projections. So these are maps that are useful for showing the whole planet. And we're going to still do coastlines, but eventually we're going to use other data sets. So it's still coast, GMT coast. To make a globe, we just saw this, -RG selects the entire planet. And now we have to specify a global projection. And I'm going to use the hammer projection, which is an equal area, show the whole, it's like a ellipsoidal shaped thing. And it takes 2 arguments. What's the central longitude? It's going to be 0. And what is the width? Going to be 15 centimeters. And then we know that to see anything, we got to paint it or draw lines or something like that. At a global scale, I don't like to draw coastlines. This is too much lines, so I'm just going to paint it. And I'm going to take, let's see what we do here. Purple, maybe? That's an ugly color to make a map with. And then minus BG. I'm just going to draw the grid lines on top of it. And that's it, I think. So, yeah, coastline, planet, hammer projection, paint land purple, draw the grid lines. See if this will work. World.sh, return. Permission denied. Ah, it's not a script. That's not executable script. How do I do it? Change mod. This is tedious. Yeah, change mod. Actually, because I'm lazy typist, I've done things called aliases that you can't do right now to do this. So I can just do X world that makes it executable. But you will have to type change mod plus X world. So when you get tired of doing that, you might look into aliases and give them some short characters. So you type it a lot. So basically, I set up a command called X that does this because I'm lazy. I encourage all you to be lazy, meaning minimize typing by automating things. But that's another workshop. Okay, so now I can run my world. I often do this too. Bang dollar, return. Bang dollar means take the previous last word on the command line and run it. Saves me typing, which is my objective. I have carpal tunnel, so I don't want to type extra, right? I want to type less. Oh, look at that, beautiful. That was a good color choice. What? Pleasant, pleasing to the eye. If you get a purple plot, or maybe you overrode the color choice. You can, you know, if you don't like the colors, you can change them. Red sticker. Dong dong to the rescue. Okay. Well, that was easy. We've done this already. You didn't do change mod, and it worked. Bash. Oh yeah. Oh, that's interesting. Magic on Windows. Yeah, it could be magic. Dark magic. We don't want to go there. Okay. All right. So I made a script that makes a single plot. What if I want to make 3 plots in this script? I can only name one session name, right? So that's not going to work. So there's another GMT modern mode command called figure. If you're going to make multiple figures, we need to use GMT figure and name a figure. So I didn't name this thing anything here, right? You can see I had no name in my session even. In fact, the plot comes up and it says GMT session.pdf because I forgot to name it. I'm going to kill this plot. I'm going to use GMT figure, and I'm going to call it world1. And it's PDF by default, right? So now I'm creating one figure. It's going to be called world1. It's a PDF because I didn't say anything else. And anything that happens after that is part of figure 1. And then we run out of the session, right? So if I run this, it's going to be the same thing, except it's going to say world1.pdf on the top because I named it that. But the same plot. So, but I want to make several plots, right? So that's why I started this. So now I'm going to do the old, call it the old copy and paste with edits, right? You copy the 2 commands that made that plot, and you paste it, and then you edit them. The last step is critical. I do a lot of copy paste and forget to edit, and then so I'm going to change this to world2. I'm going to change the purple to, oh, that's not a color. Any color. Name a color. Green. Okay, green. And I'm going to try, so all these global projections are all very similar. They take a central longitude and a width, and they're just different flavors. There's a whole bunch of them. So I'm going to do one called Robinson. I think it's JR. Robinson projection. It's another projection. And it's going to be green. And now I have 2 figures. And well, we expect this to run. It's going to run this one, call that figure 1 of world1, world2, and then put up all the figures that the session created. I got 2 figures. And they're different. You can see the projections are slightly different. They're kind of, this one had a haircut on top of the pole there. So the pole is actually a line. The So that's very distorted, right? So if you plot Santa Claus to scale, it'll be a very strange looking person. It'll be everywhere.
I thought I was going to put the two plots the same page.
Ah, yes, that's an excellent point. We're going to try to get there in 5 minutes. But yeah, right now you get separate figures, which is okay if you're having a session called My Thesis, and you have all your 50 figures in the thesis. They're going to be separately named. From what? Yes, so if you are plotting away on figure 1 and you start plotting on figure 2, and now you want to go back and plot some symbols on figure 1, you can just call figure 1 again. And it just changes the focus back to that figure. So that's good. Okay, so we have 2 figures, but we kind of want to put them on the same figure. You want to have a and B kind of situation. So that's going to take us to something called subplot. And that's going to be subplot in 5 minutes. The subplot is kind of like at MATLAB. You set up a matrix where you want to plot things. It can be like 2 by 2 or 17 by 7. And here we're going to have 2 by 1. We're going to have 2 figures. 1 column, 2 rows. So I got to delete this figure business here. I'm going to get rid of, actually, let's not do that. We have a working script, yes. We don't want to delete the working script. So I'm just going to close it. And I'm going to make a duplicate. We didn't talk about this. I'm going to copy world.sh to worlds.sh. We're going to copy what's in world and create a new file called toworlds.sh. That's one way. And then I'm going to open that file in my editor. You can call it anything you want. Open toworlds.sh. It's the same content, obviously, but now I can delete things and not feel bad about it. So I can delete the figure calls. And if I run it like now, it's going to put 2 maps on top of each other. Very ugly. In fact, let's run that. 2 worlds. Oh, right? This is ugly. Because that's what I said. Plot this and plot this. We don't want that. So we got to organize this subplotting with 2 separate windows. So GPT docs subplot takes it to the subplot menu. Now, subplot is kind of complicated because you have to set up a bunch of stuff. I'll use as few options as possible for this case. So you can see, it depends what you're going to do. Like this is shorter than the coastline options. There's a lot of modifiers and things. But basically, you have to do, like for Insets, you're going to do a subplot begin and define number of rows versus number of columns. So you're going to have 2x1, 2 by 1. And then there's some options. And then you're going to have a subplot end at some point to turn it off. So since I'm challenged for time, I'm going to put in here GMT subplot begin 2x1. And well, I have to specify the size of these things. All right, so what's the size of the panels? So you need to specify the size of the entire figure with several plots in it, or the size of individual panels that make up this composite figure. And I think I chose the former. So because I have 2 minutes left, is that right? 2 minutes? It will be a little bit quicker than I would like to do, but minus F, lowercase f, selects the figure dimension of the entire thing. And I'm going to do 16 centimeter by 25 centimeter. That's my whole box. And I want no margins. And how do I go from panel to panel? Right? I mean, I got to plot in one panel, I got to move to the next panel, and the next panel, and next panel. And that's done with a lowercase minus c option. So the second coast plot, I need to do a minus c to move to the next panel. So it's going to automatically go to the next panel, which is going to be row by row. If I want to go to a specific panel, I can specify that too. But usually you just go through the order of things. That's the simplest thing. So is this going to run, Joachim? Yeah, okay. That sounds full endorsement. 2x1, no. Where's that come from? Thank you. I would have crashed and burned there. Okay, so begin 2 by 1, magic size of the thing, no margins, and then 2 plot commands, and then -c on the second one. Oh, yeah. Okay. As I said, we're all new at this. Once you set up the subplot, you're saying what the dimensions are of these things. You can't then decide, oh, I want to plot, this wide. So for subplots, when you do the projections, you can't give the dimensions because the dimension is provided for you because you already set up the panels, right? So we got to take out these 15C guys. Well, it didn't. It depends. For projections, you can't, I think. Not there. -1 minute. So, no, actually, 0 minutes. Okay. So now I got, because the 2 maps are different heights, it's not a pretty equal size thing, but I got 2 plots on the same piece of paper. My last thing that I want to do is, since lunch is here, I want to label these guys, the 2 plots. I'm just going to do the default labeling. You can label it in any way you want, but the default is should be A, B, C, and so on. Right, like that. So if you're going to make it 3 by 3 or something, it's going to be A, B, C, D automatically. If you don't like that and you don't want the parentheses and the font and Y's and whatever, those are modifiers to change things. But, yes, I can, since I'm rushing here. Yeah. So yeah, so -A turns on auto tagging for each panel using this format. If you want capital Roman letters, you can. It's just modifiers that changes things. And since we are 1 minute over, I'm going to go 1 more minute over and add 1 more plot to make it 3 by 1. Because that's just copy this line here and make it a 3rd line. Change the projection to something different, like maybe, I think that's Winkle or something. I can't remember. It's another projection.
The Eckert projection and the scientist that is building this name for are not the same.
Eckert, yeah, that's E. No, I don't think, no, it's not the same guy. Okay, that's JK. We'll do Eckert. Yeah, okay, and then begin. Now it's 3 by 1, yeah? 3 by 1. So now I'm making a 3 by 1 plot called ABC with 3 global projections that are all different, and we should change the green to whatever color. Color? Orange. Golden. Oh, orange beat you to it. That's shorter too. Orange. Okay.
Do we have to take out that -C on the line number 5?
No, because the -C means move to the next panel. And I want to move to the panel after each plot because there's going to be 1 plot per panel. There's no overlays in the panel. So that's why the first one doesn't have a -C because the default is to go to the first panel. But after that, we got to tell it to move that. We could put a -C there too, but I'm minimizing typing, so that's why I'm only doing the C's when I have to be there. Okay, gonna run it. Okay, did it look okay? Oh, look at that. The fantastic color choices. So now we have a subplot with 3. And if you want to make it 3 by 2 and so on, knock yourself out. It's the same thing. You just keep adding more plot commands and moving around.
And then do not need.
That's right. You can skip some. Yes.
You can just say that what the diagonal.
Yeah. So the -C option. Well, you can do -C row, comma, column. Yes. So if you go to the subplot page, you'll see somewhere GT. Oh, it's a common option. That's right. Common, quick reference, common options. There, okay. Here's the -C option in its full glory. You can see things are in bracket because they're optional. But if you want to go to panel 3,2, you say -C 3,2, and you go there and plot there until you changed it again. So yes, like Joachim said, if you have a 3x3 and you want to plot the diagonal, you will say C1, C2, C3, and the other ones will be blank because you didn't plot that. So you can move around and do all this stuff and go back again and keep adding to the plot, because nothing is finished until the subplot end comes, and then it shuffles and figures out what to do. So I'm out of material and it's lunch. If you have questions about any of these things, we can chat during lunch, and we'll come back again to haunt you, I'm sure, in the next session. But thanks for playing along, and let's get some tea. You guys online, I'm sorry, you have to get your own lunch somehow, or come here and pick it up. I'm not sure if did we get extra ones? No, we didn't get extra, so there's that. Okay, so we'll see you guys back in 90 minutes, I think. Our time here, this will be 1:30.
Can you leave your code on for the 2 worlds?
Yes. I'll leave that up. Is that okay?
Thanks. Yes, muting myself.
Nice.
Yes,
okay,
yes.
So I will talk you
Yes.
about lines, symbols, trends, and stuff. Already covered the part of it, so part of it is going to be some repetitions and some things that we did not mention. So, but this is also another part of maps. Maps. You always draw lines, simple things, ready. Be closer to the, not move from here. Yes, yeah. So yeah. So we're gonna look at how to draw lines, different lines with different colors. You should have a thing to maximize. Anyway, this doesn't really matter. Oh, no, not this one. No. I go directly to the point. Okay, that's the same slide. An older one, I dropped the thing on top because I thought it would work, but it's not working. These all are different type of lines. Even the last one, except that it didn't work the way I thought it would. I thought it would be curved, but because of the text is not curved, so I just dropped it from the slides that you have. Do not have this last one because I chopped it that one. Did not exactly work the way you intend. So lines are made with the plot command. And the plot command is one of those that scares when you look at it. And this is highly concentrated. Okay. One thing that you can use to easy just a little bit navigating to the manuals is if you see them underlined on that option, and you go directly to the sub option. Okay, so lines are made with W minus W option. Is it? And even here, you have some explanations, but it's not complete thing. If you want to learn how it works with all of them, we go to the cookbook. This one? Yeah. No, not this one. Sorry, not vectors. No, yeah. Transferring. So we have the manual and we have the cookbook. The cookbook is a complement to the manual with more examples. But it's a single file, large file. It's not so obvious how to find things in the cookbook many times. So many of the pages have links to the specific parts of the cookbook, which is what I use. So a pen is made with the option, the -w, and then you specify the thickness, the color, and the style. The thickness is the thickness of the line. You can, when we specify the thickness, we can add the units. Paul did it all the time, so I'm even lazier than him. I never do it because I'm a SI educated person, so I don't care about inches. And by default, GMT uses centimeters. So if you don't put an unit, you get centimeters. We'll always put 15C. It's okay, but you don't need to put the C unless you make one file in GMT saying, okay, what I want to work in inches, and then you create a GMT conf file that says it's in inches, and then you can use it. Otherwise, if you don't say anything, the width are by default centimeters. And with an exception, we always have exceptions. The symbols, it's the symbols, not the symbols. One of them is with points. Okay, when they come, we have the width, we have the color that we already seen. Either we type the name of a color, or we specify a color in RGB or even other color models that we could also use, but we are not going to use. And the style. What is the style? Oh, you have here the translation of the names. Paint. Default P stands for points. Points is an unity of size. It's 1/72 of an inch, 1/72 of an inch. But it's a dimension as well. We are used to points, and we like points because many things, when we select the font size, we select an integer number, and we like integer numbers. Every time we can, we avoid decimal numbers. And these things that in this range of sizes, for example, the font sizes, we use points because we say an integer number. So it's 12, 18, 24, and not 0.253 or things like that. So a point is a unit as well. This is the definition. Okay, quick, and an example that we'll see. What is the style? The style is exactly that. Do we want to have a straight, continuous line, which is the default, or we want to have dashed lines, or dotted lines, or dash dotted, or complicated even more, saying the pattern of the length of the dash, the length of the other one, and the offset, all of this, it is made with a style parameter. If we don't specify the style parameter, it means it's a continuous line. So that's what we're going to use in the example, and we start replicating this example. So this, we're going to build it on top of the other. First one should be very easy. So what we have to do, we have to create a plot with a certain dimensions, and we're going to say to plot a line. I choose to plot lines because you only have to give it 2 points, so we can make it in the script a small one. You don't even have, you need to have a file. You'll have the coordinates as we need. What we need is you have to have the plot, and in this case you are not using a map projection. We are just doing the plot. So it's a Cartesian plot that goes from -1 to 11 in this example. So we have to start doing that. This one. So I'm Windows. I never do this. I do this almost never. I always do a batch. It is quicker. So now it's slash. No, it's the. I should know. Slash. Env. No, bin env bash. Bash. Okay, go bin slash env. Okay, and also, well, when we program, we start to do this. We start the loop like a loop. We begin and end. GMT begin. Oh, don't call it lines, the name, and will be PDF, GMT end, show. So, and here, we need to make the frame. Oh, yeah, it's there. So, GMT plots, right? We use it GMT plot? Yeah, already, okay. GMT plot, and we need to specify the limits of our figure. So it's minus R that we saw, minus R. In this case, it was minus 1 to 11. It's a square. Minus 1, no, minus 11, right? Yeah, we have to tell it. In this case, it is a Cartesian plot, so we use the symbol for the Cartesian plot is X. And we give it dimension. So we can give it a 15 with the C or with O, not here. C, 15. Can I have the C? Okay. I can do this, or I could drop the second one. Okay, if you can give only the width, or you can give it the width and the height. If you only give it the width because it's linear, it will compute the height, and because it is a square, it would give the same thing. So you can have it here or not. If I put there 10, I would have a rectangular plot, right? Oh, things that we need more. Right? These. The first one was a red line with a thickness of 1 point, I think. So it was minus W1 P red. Okay. Okay. Except that this doesn't work yet because we are telling to plot a line and you haven't tell it yet the coordinates of that line. So from memory and because it's only two points, I'm going to do it this way. Echo was the coordinates. So we have it. This point here is 0, 0, and the other point is 10, 1. So I need to have those 2 points in a file. Oops, yeah, sorry. Echo 0, 0. I have to use the redirect. I call it T. Use this often, means temporary file. This is 1, and then I do again echo 10, 1, and then that's the first thing. T dot that. Maybe. So the first one you have this the greater sign. It means it will create a file with that name. The second one we don't want to delete. If that file existed previously, it will be deleted. So the second one, we don't want to delete the first coordinate. So we add to the file instead of starting a new one, and you use superior. So now we have a file called t.date that has our coordinates. We can put it anywhere in the command. The order does not matter. No, the order does not matter, but there is still part of the command. Yeah. So, that one has also coordinates. So we'll add a frame with the coordinates, and we can it as. Is it automatic? No, yeah, it was automatic. I think. Yeah, I think it was automatic. But let's try it with one. So we want to plot just the left and the south of the west and the bottom. So we say minus B, west, south, east, north. And we can put minus B, A, F. That's the default. BA is the default. So okay, yeah, the default. So, option B used to be the most terrifying option in GMT. Maybe it's not. There are some now that took the place. Because this one was broken in different sub options, and you can use it separately, like I'm doing here. So the first one is just telling what the axis that will annotate and the ones that will draw. The uppercase annotates, the lowercase just draws it and does not annotate. And the second one says, well, we put the ticks. And if you put A, it says use automatic. Oh, A, it does not do G. I have to do the G for the grid. AFG. Maybe you have G. So let's try. That goes X and Y. Yeah. It calculates automatically in function of the dimensions of your axis. This case was not. No. Oh yeah. So I already have one called lines. Line. I don't want to. You don't copy my name. Line. Or sh, because I already have one with the same name. I would delete it. But okay. Okay, we have it. Now, on Windows, you can do it, and I think you wouldn't care. On Windows, you don't need to change the mode. You don't need to make it executable, the script. You just use it. But the other of you that are using Unix, you have to do the change mode step. So, I have here my shell script. I have too many, so I have a lines. Where is it? Line. Okay. So I should be able to say line, run. But okay, you do. Okay, I will do it here. Chmod plus X. I think you will not ignore. If I ask for the permissions, he will show me the permission as executable as well. But if you don't do it, it doesn't care. So line. Something should have shown up. Yeah, taking. Yeah, that's why I prefer the PNG. It goes faster to load. Okay, so we have our first line, the red line. And the rest of it maybe, or will become, or don't have time, or too boring. We'll do some of these. Yeah. Ah, okay. Why I wrote echo. What it did, where is that? What it did, I will type this on the command line, okay? Echo, hola.
Yeah.
You see? If it repeats what you add after the echo.
Yeah, I get echo, but why did you confirm
Oh, because it's the coordinates of this. Because I'm inventing the coordinates. I have no. We don't. I am not using so far a file with coordinates. Yeah. So you want to plot the coordinates of something, you would need to have your data. Okay. Here I'm pretending that we did all data and creating the data directly. So yeah. This is the coordinates of this point, 0, 0. So it's a line that starts at 0, 0 and ends at 10, 1. It could be 10, 0. It would be an horizontal line. So I'm just okay. Let's see here. Cat t.date. No, not this one. Not this. Not this. It's in here. Huh? Yeah, it's in. Yeah. So it's here. So he created this file.
Oh, I think my question is more like, what if you didn't use the echo command? You just typed in 0, 0.
No, because it would be a command. Every time you type something, I have too many. If I type 0, 0, it is expecting that 0 to be a command. And you will say command not found. Echo is the command. And the echo takes an argument. And if you say superior, it will redirect into a file. So Paul gave it more complex one. Then when you type inferior, end of file, and then can you type many, and at the end you will close. When there are few, this one has less two lines. That's why I was. No, it's just a file. This is a file. I will do that. Yes, in that sense. Cat t.dat. Okay, it's the same thing. We just created a file that has only 2 points. That's the extremes of this our straight line. To have data to simplify the drawing the lines and make it the simplest that you can have. If you have a line, you need at least 2 points. We'll do the same thing with symbols, and there we can even be more spare and only have 1 point because the symbol is just one point coordinates. But for a line, you need 2 coordinates. So I just created that one. So now you see we're gonna how to do the next one. What's the difference of the next one? So I choose not to put them all in on top of the others. What changes? The y coordinates adds 1. What's changing more? The color and the thickness. So please go ahead. Yeah. You only have 2. It's not 0, 0, it's going to be 0, 1. It's going to be 10, 2. And it's not red, it's green, and it's not 1. Oh, and that is 3, I think. So, and you can leave the other ones. The other one before. We're going to do it incrementally. No, let's see. So we can leave this one and kind of repeat this. No, okay. We have to repeat what we have. Okay, I'll do 2, right? In my VS Code, I use VI, so simpler. So now here you have 1. No, 0. It was 1. And it's 10, 2. Okay? 1. And I'm going to copy the line, except that now you don't need anymore to tell the region or the projection, because it's the same. You only need to put that the first time.
For line 7, are
now
you?
The other ones. I can delete this. No longer needed. Nor this one neither, because it's to specify the frame. You only need to do that once, right? And it's not red and it's not 1. See what we have to change. Where is red, we put green. Where is 1, you put 3. Okay. Put 3 or more. Okay. And we'll keep adding.
So in the old GMT, this is called PSXY.
In the old GMT, this is called PSXY. You cannot call it PSXY here because you will complain saying that you did not study the lesson. No, yeah, it's the same one, but you have to call it plot. Inside the modern mode, they have to use the modern names. Why we change these? Because we are hiding the strong link with PostScript. So like this, you are ignoring that it's doing PostScript, it's converting. So a name called PS, all the names used to have PS to say that it was producing a plot. Not all of them, but many. But here we are no longer so tied with the PostScript, and we drop the PS. But you are not going to call a command XY. It's just 2 letters. It's too short. So, and that's the common name in all language. MATLAB call it plot. All plotting package that plot have one thing called plot. So we also have one thing called plot, and one is this.
So for compatibility, PSXY still works.
Yes, it's exactly the same program. It's exactly the same program, but it has 2 different names. Inside the modern mode, like we are, when you type GMT begin, he wants the modern names. If you type it on a command line, you can do PS. If you type with a single command, you can still use PSXY. All the rest is the same. The program is the same as a double personality.
For line 7, are you going to create a new file?
No. Oh. That happened to who? We did not like, yeah, because it's open. If you don't mind, I will change to PNG. So, goes faster. Oh, not this one. I keep opening the. So you got an error from the Go script because you wanted to write in a file and the file was open and the system did not allow it to write and it gave us this error. So now he opens with a different program. That's what I have by default on Windows to open the PNGs. And so you have our second line. Third line. Okay, it would be the same, but no point keep repeating the same thing. You have a style. You want to make them dashed. You want to make them dash, you just use the. So first, I'm going to copy these lines. Okay. And now it's going to be 0, 2, and then 3. And what does the line has? It is blue, and it is dashed. So the thickness, well, you can leave it with 3 or with 4. It's not the point. So make it blue. And now comes the dash. Okay, you can't say dash or dash it because I also say originally you have to say dash it, but you can say dash or dash it. Again, run, just this. And yeah. So here we have it. In here I have to delete the other ones because it keeps adding new files. So I want dash, it's simple. You have a dash or dash to the line. Okay, I'll go back one detail on here. I like this program because it's very easy to zoom. Okay, I'll go back to this. See, square edges, our dash lines, and with square edges. Dotted instead of writing dash. See, there. It's more boring to change the coordinates than do the rest. So now it's 3, 4, and actually, see, what do I have in my example? It's black, I think. No, it's black, yeah. It doesn't really need to be equal what I have in the example. It's the idea to see how it works. So I don't have to specify the color. If I want black, I can just remove the color. If we don't say the color by default is black, and then dot or dotted. But if you have dotted, in Portuguese there are no double consonants, so every time there is double I put 1, and then I put 2 when it's only 1. So dotted I think is with 2 double T, and dots has only 1 T, so it works as well. So you can have it there. Oh, now we have the dot. Oh, and again, keep opening the wrong window. Okay, I wait a little bit. I do quickly for you, copying the line and changing. Maybe you are taking a little longer. Are you following? You have all of these? Okay. So dash. If you want the same line, you have 2 options. either changing the coordinates like I'm doing, or you could shift the same line with saying, there is an option that say shifts vertically or shifts horizontally. So I could have obtained the same results with only one file with these coordinates, because I can say change the origin of my plot, and then I will move it up with the same. Yeah.
You can program it. So the idea is to write a loop in Bash or Python or another language. The loop, so it's another. That's for it.
Because we're only adding one.
So I made it the simplest way that the issue is not with the data. You have the simplest is a line, 2 coordinates, but to not plot them all one over the others, I need to keep it, change the coordinates so they keep adding on the file. Well, on a real case, you would have a file with your data. In a real case, you would have your data inside a file. You would plot the data that you have. Instead of using the, no, this one is the, instead of creating the data with these, you will get your own data. And then you would only use the plot of that file. Okay? This is the simplest you can have to draw a line.
So that last one is blue, remember
No, the last one is black.
Oh, it's black.
Because I removed the color. Okay. You can have the 3 things: the thickness, the color, and the style. But they managed to find if you jump one of them, 1 or 2 of them. I think I could just type -w dot, and it would use the default thickness, which is thinnest, a very thin one. For dot, yeah, you could see it. Yeah.
So if you were using the GMT5 syntax, do you have to use the overlay and all those other flags or no?
Yes. Yes, that's what we are not using now, because the rest is exactly the same. The syntax for the lines, the pen, the thing is the same. What you don't need to do here is to know how to use the minus or minus k, superior, and things like that. And the last one is going to be only a minus o. The first one is a minus k. Okay, that's what the GMT begin, GMT end does for you. It does all those guessing for you, so you don't need to use it anymore. And not only, you don't need to repeat the minus r again. On GMT5, you would be obliged to say this. Even if it is empty, because you would need that. But now you don't need this anymore. He knows because he writes that in the file. Yes. It's more complicated because if you do it with the shift, you have to probably, okay, even you would give, we are giving it the simplest way, giving the size, but you can also give it a scale. If for doing with the shift, you would better do it with the scale, giving the map scale, and then you keep adding the dimension or the size of the shift. It's more complicated. That's why I picked this one. Just give the coordinates and go away. Okay, no, this one, no, okay. This, but we have more. Okay, quickly. And we have dash, we have dot, and if you want dash dot, we type dash dot, separated with a comma. So dash dot. 4. So now it's 0, 4, 5. What's the color? Is green. Okay, can have the back the color green, and then we type dash dot. Yeah, this one. Yeah, it's gonna work like this because you can do it this way. Yeah. Dash dot. Yeah, you should. Yes, because you can do dot dash. You can start with the dot instead of starting with the dash. The order matters. Oh, yes, the order matters. You can jump if you want to. When you jump one, use the default.
You need a comma?
No, need a comma, no. No, no, no. You would jump. You would. Okay.
Get rid of the three.
Okay. Let's see what this. Ow! All the time. Nope. It didn't like pen name green. Not recognize it. No, it did not like. So you need a comma probably. Yeah. Yeah. Still no. Okay, I have to close them. So that's what we do when we are not sure. We experiment. So no, it's not liking that. So he needs. I'm not sure about that one. I'm not sure about this dash dot.
One word.
Oh, it did work, okay. No?
One word.
One word?
One word.
Oh, okay. It's not. So is this dash dot? Dash or and dash or dash it? Yeah, we're going to symbols after.
No, you can just use a dot and a dash.
Yes, yes. And then you have no comma. You can also, yeah, you can do this. Dash, dot. Yeah, that's the original. This is GMT1 or 0. The words came after. So yeah, you can. I was going to cite that after, but that one, this one I know it's like this, and you don't have comma, don't have any separation. So Paul is saying that if you use words, you type it dash dot, then then the combinations make it complicated. If you want to do dash dot dot dash like this, you just put you can do these and these, for example. Then you can invent whatever you want. This would mean a dash, 2 dots. And then you can make all combinations that you want of this. You can complicate this. It's actually, then it becomes simpler to do it with the symbols than with the letters. So okay. And then you have dash dot. Because these examples grow a little bit in the level of complexity, these ones start to be, now it starts to be a little more. So this is the pre-made example. We have the dash with the square edges. But we might want to do, and this is the dash dot with the thinner line, but look at these ones. They are no longer edge, square edge. And there one thing in the PostScript that is the end line termination. Well, you notice that when you have thick lines, if you join two thick lines, I don't have an example here, but if you join two thick lines, you see that they don't join with an angle. They will leave an open space. They do not join correctly. You don't see that when you have thin lines, but you start to have thick lines. You simply do not have two lines that join, and then it's very ugly because it's big and you see an open space. That's when it comes out the line termination. So there is one thing in the GMT that comes from PostScript is the one is okay. Let me go to the manual. Go to the manual. Go to the manual. GMT conf dot GMT docs. GMT conf. Is this one? Cool. Yeah. You open something. And then it's should remember is the font. No, it's map. No, it's map or font. I have my notes here. It's PS. Is the PS. PS. PS cap. Line cap. Okay. PS line cap is one of the hundreds parameters they can use for fine tuning. PS line cap will make a round half circle, you will add an half circle at the end of the lines. And if you join two lines like this, they will join perfectly, the two circles. If you do it with the square edges, you can later try to find, there is a cool examples. Then you'll see the opening angles, and then it's not nice to see. So we're going to use this option to make that dashed line with the round ends. Again, I keep opening the debugger. So, yeah, that's one more. So 5. So we go 5, 6, and the line is dashed, flag. So just dash. More, and we're going to use that option. Okay, these options can be used with a program, with a model that is called GMT set. If we call a model that's called, use a program called GMT set, it sets the values of this modifier, and not modifiers, we call modifiers these options. But GMT set writes a file, and that file lives during all the entire session. And if it is in the classic mode, you will live until you delete that file. You also have a mechanism to do it online, and it will be operational only during that command. Is if you type minus minus, do this. PS the name. Line cap, PS line cap. Oh, and the value. What is the value? Is no line cap. Round, something I was looking at. Round. So I would say equal round. Because there are more. Okay? So that means you will do that only for this command. And you do this, all of those parameters that you specify in the GMT code, you can use it like that. It's handy because they will not be active in the following commands. Because, for example, you want to do this, and next you don't want the round cap anymore. So you would have to unset it. Otherwise, it would be active for the next line to come. If you do it like this, you will apply what is like this. Is to put minus minus and the name of the variable. You can put as many as you want. If you want to put more, you would have minus minus, the name of the next, equal, and its value. So, yep, that should be. No, again, every time set error, line. See, now they are round. What's the time I'm taking breaks? When I made this now a bit harder, I didn't mean this one, because this one is a bit even harder than the ones above. It was just to separate these ones from the ones above. Because this one is also a line, but you can annotate lines with text. That's what actually it has. And on top of it, I wrote about the text. You can make much more complicated things with the lines. You can have a line that is annotated with symbols, with texts and things, and use that. But maybe I'm not going to this one. But for example, this one is still a line. That's one thing you can, if you draw, if this dashes have 0 length, what do you actually have? Only the end caps, the 2 halves of the circle. So when you plot them, you get the circle. But you are not plotting a circle symbol that as we'll do after. You are plotting a line, but that line has a dash of 0 length. If it was not the line cap round, it would be nothing because it would be a zero length. You would not see it. But because it's 0 plus the 2 halves, you get circles. How you do that? Now I jump it. Or let me see if I do it by my own. Here I think I jump it to 7, 8 or something like that. It doesn't matter. So, and it's not 3 is too small. I have to put something larger. Like this, put 15. And now we can have it in the no, not this one. Yeah. Where are they? Yeah. You have to read these to go to the point. You can specify the length of the dash or the dot and the length of the interval between them and the repetition. You can make very complicated things like that. But you can, for example, say that the line, the length will be 0, and the separation will be a certain length. So let's try that. 0. So it'll be, my dash will be 0 length, and we'll have, and I use an underscore, and I say it will repeat every 15 or even more, because if I have 15, maybe I say at least 20 points. Okay? So 0 length, the line cap will do both of the ends, and then I say then add an extra space of 20 points, and then repeat. Maybe it's too close, but let's see. Oh, not this one again. Yep. Nope. A colon offset. Yes, it's the colon offset. But if you don't do the colon offset, yeah. What happened? They are there, but they are all on top of each other. So you see a thick line. It's a thick line made of many circles. And I did not change the coordinates, I think. That doesn't matter. Now I changed the coordinates. 0, 7. The offset is 0. I have to put a 0 for the offset. Yeah. Why didn't it change the coordinates? 0, 5, 10, 6, 10, 8. Should have done it. Or maybe it was too thick. Again, okay. If I increase the spacing, I would increase the spacing between the dots. So, what am I? Yeah. It was, hold on. I started. Probably take too long on this one. So I will not plot the last one. I will go to the symbols. It is such that you can extend these, and you can put big dots, small dots of different colors. If you plot 2 lines offset of the spacing, that's what was the other example. I think I will jump this one. So you can continue complicating these even more. What you have to do? Play with the style of the line. So you can do these in thin or very thick. You can do all of that. And after a while, it's just a question of reading more lines of that manual to see how you do the next step. The basic is simple. If you just say -W, you will plot a default thickness, a default color, and all of that, and you get immediately your line. So this was for the symbols. I will jump the other one. Now this was for the lines, and we also have the symbols. Okay, symbols. That's right. again, the same thing, the first one, then start symbols. Let's start on with another one. Symbols are also made with the plot command. So I will start a new script. You can do Control or Command N. I just start a new one. So it's not lines now. It's symbols. Okay. Same coordinates, so you can go to the previous one and copy first line. One. Yeah. Okay. No. We use the same frame with the same coordinates and same Cartesian thing, except we don't have these. We have the same for the frame. I'm repeating from the previous command. Annotate west and south, and the other one's just put ticks. Make a plot of 15 centimeters width, and we are going to plot symbols. Symbols. Not here, not there. Okay. Plot. Symbols. Symbols is a huge list. You have S, they start with the S, and you give a code for the symbol, you give it a size, a unit, and depends on type of the symbols, you can have only the 2 coordinates, or it needs to have more, needs more things to specify. For example, you can draw an ellipse. If you draw an ellipse, you need to tell it the axis, and you can tell it the orientation. See? So if it is a more complex symbol, you need to provide it more information. Once you're going to use these examples, just the simple symbols that you use everywhere, so you need the 2 coordinates, x, y. Symbols, you go here, and it's long list. But it's also, most of them are very easy to understand. Minus means a dash, plus, it's a plus symbol. C stands for circle, S stands for square, T stands for triangle, the inverted triangle, I don't remember anymore, and then you have H or hexagon. So some of them you don't need to consult the manual to know, other ones you'll need it. And I'm leaving the vectors for Eric with even more longer options. So let's look at this. So first one, just a green circle. A green circle, you don't use minus W, you use minus S. What is the symbol for circle? It's a C. So can be over there. Minus S, C, and next, the size. Size here is not points, it's a dimension. So it's by default is centimeters. So I can put 0. The size is the diameter. So yes, is the diameter. So if I put 0.5 of a centimeter, okay, this is the size. You need the coordinates, and that symbol was green. So if you want to paint symbols, you need to use a different option. It's minus G, capital G. And then you put the color, same way. Green, green. Yep, but I need to plot it in at the coordinates 0, 0. That one was 0, 0. So I do again echo 0, 0, pipe, because now it's only one coordinate. I don't need to write a file. I can just send it directly the coordinates because it's only one. If I had more, like I would like to have time to go, you need to have a file with the coordinates of all the points. But if it is only one for demonstrating, I just can tell it, plot it at 0, 0, and then I use that symbol, the pipe. Paul mentioned that it will send 0, 0 to the plot command that is expecting to receive coordinates, and it will receive them via the pipe, and you will know plot the green circle at the 0, 0 coordinates. Oh, yeah, there was sim. Okay, mine I will just call sim here. I do now sim. So here we have it, our green dot. Oh, yes. Oh, sorry. Yes, again. You have to do chmod because you created a new ch plus x, and the name of the is the name of the file. Ch. And if you start typing and use arrows, your shell will remember. Oh, no. No, you have to do, no, come on, that's other language. You have to put the exclamation point, and then we repeat. Okay, forget that. Just chmod plus x minus sim.sh. You have to do it, otherwise you get the command not found thing. So okay. So that was the green dot. The next one, oh, no, I deleted too many things. Symbols. Oh, no, I screw it. I deleted my original, no, lines. Yes, I deleted my original. No, it's here. Yeah, no, yeah, okay. I have another one here. I think I deleted, but no. So what's the difference between this one and this one? It's this one has the fill. I think you can have also can tell it to draw the yes. So there was the outline. Yeah, thank you. So you can plot an outline, and the outline is just another line. So we will do like we did for the lines. This one is a thick line, or thick. It's a line with 2 or 3 points of thickness and blank. So we just do exactly like we did before for the lines. Add to that command. Again, not this one. So A minus W, let's say 2 points. This is a blank line, thickness 2. Right? No. I know. I forgot to change give it another coordinate. So if I want to add, I have to move the points. So now I will do this. So again, I will do this 0, 1, 0. This one has no place, and from now on we simplify like we did with the lines. No longer need the R, no longer need the J, the B, nothing of that. What we need? Yeah, the symbol, code, the size, the color, and the outline. So this one will repeat. Oh, yeah. If I make the line too thick, I'll see just the line. But now you do what you want. I will jump a couple of them. So this one is, I specified the color here. It was a dark green that I invented. Because all the rest, this is a dashed color, dashed outline. It's exactly the same like we did with the lines. So once you know how to plot the pen for the lines, it's exactly the same thing, the pen for the symbols. So I can keep on. This is dash dot, and this one is transparent, the last one. So maybe I can jump the others and put this. This one is position 6, no, 5, 0. No, good way. We'll keep opening the same thing over and over. So if I want to do the other one, this the end one. The position was this 5, 0, 5. It's a circle, but now he has no fill. It has an outline. You want me, Paul? You want shift plus? No, no. Yeah. And make it a bit larger. Shift plus. So now what is this? P? No, no. This. So this one is no green. So if you want to make it transparent, no color, then put a minus. Yeah, I saw that somewhere. It's not obvious on the menu. And then, no, don't say, no, it's a circle, and you have, yeah, something like that. No, not min G, yes, not minus G at all, but why I have that? Yeah, yeah, of course. Yeah, of course, you would not paint it. I saw that in an example. It's being edited. Okay. Don't complain more. Okay. Anyway, the coordinates are, it should be here. Or then, okay, I know. I copied the coordinates, but my pre-made example goes from -1 to 6 and not -1 to 11. That's why maybe we change it, because the last examples, otherwise, that's why I was copying the coordinates and it's not correct. So I will change it from, instead of 11, I'm going to put 6 to have it equal to these ones, so that it's 6. Well, so instead of 11 here, I put 6, 6, and the rest is the same. Okay. So I jump at these examples because basically, well, would be not be too boring. It's just using the outline pens as we did for the lights. And the same goes on. This is an example. If I want to plot a star, I used A. I go to the manual, I see the star is A, the code for the star. This is a circle. I think I added something else. This is a diamond. A diamond is a D. But all of these, some are obvious. You remember, the other ones are not obvious, and you have to go to the manual and read what is the code. These are simple ones because you only have to specify the coordinates and the size. And then if you want to fill it, you put a color. If you want to put a cross or a square or something. So these are the symbols that you have everywhere. All programs. No, let me look. No, I think it's the same thing. No, I use pipe in all of them.
Yeah, so for lines, we redirected.
Okay, yes, because lines need 2 coordinates. See, I have the coordinates of the first point, the beginning, and the coordinates of the end. And you have a line break between the two. I cannot make the same thing to draw 2 points. Understand? This I could have echoed this into awk and say print /n new line, and I would complicate it that. But I think it's simpler to just do redirect. Yeah, I could have. Yes, I could have done the same thing. Yes, I could have. I could have done this. Echo 5 0 t dot, and in here t dot. Okay, I could have done this, but I need 2 lines for the same, for plotting 1 point. Whilst here, I do everything in a single line, and I think it's still clear enough to be seen. That's why. This is similar to the lines, but you only need one point, you only have one line like this. But if you only need one, you can make it simpler by echoing directly into the program. No, you don't pipe the line breaks. No, you have to pipe it through another program that would write the line breaks, because it needs to find for a line that you have a different line, and you are not sending in, for example, 4 points, which are the coordinates and the size of this axis and the size of the other. So you really have to tell it one line, and then it goes the next coordinate is another line on the file. Yes, that I could go into pipe into awk and think, but then I would complicate this. I don't want. That's why I pick it only 2 points to complicate the less, to concentrate only on how you control the lines and not what you are drawing. What we are drawing just a line on the board is is not particularly interesting. So I can leave it this one, or so. So these are the symbols. GMT has also a collection of symbols, not very extent, but they have a collection of symbols that are all of these. Where are they? No. Where? Yeah. In the cookbook, which if you search for custom symbols, GMT has a language to plot what symbols we want. The language, it means that you can program your own symbol. You have to follow the rules of the language. There's a separate part of the manual that teaches that. But he also has, these ones are pre-built. You address them by their names. Hexagon is like the hexagon, but you have others. You have these ones with these names. These are also the QR code of GMT that was added recently. You have these symbols. They are pre-made. A symbol is like this. You can fill it with the color that you want, put the outline, the color, and the style that you want, and things like that. For example, and I use it in the example, a couple of them. Flash, hurricane, the Pac-Man. This is star something. This is the sun. See, those ones are simple, but these ones are not simple. They're also symbols, but these do not come with GMT. You can use them because you can transform anything into a symbol. You can make a complicated plot of GMT, and say, okay, now this is a symbol, and I will plot those complicated things as you were plotting circles or stars or points. So basically everything can be converted into a symbol, and you use that as a symbol. Those that come with GMT are simple ones. These are examples of simple ones. So this one is the coordinates 0, 5. Let's do the flash. Okay. One. So coordinates is 0, 3. 0, 3. And now it's for plotting custom symbols, use the letter K. Okay, it's in the long list of the symbols of the plot command model. Use K is the name of the symbol. No, it's not the name, sorry. K means it's a custom symbol. And then you type the name of the symbol. Flash. And then the size. That one I think I don't remember, but 0.5 small. Let's say I use it. I don't know if I use it 3 or not. What did I use? Symbols. Write it down. Yeah, 1.5. I use it 1.5. Those ones are 1.5. Something like that. So, custom symbols are instructed by the lowercase letter K. and then the name of the symbol. What you can choose as names, only those from that list that we have on the, yeah. This shortlist, there are not many, the ones by default, but there are already many symbols that other contributors have offered. So you have many geological symbols. You have a large collection of dolphins and whales. Some meteorological symbols. So a symbol is a file with a certain structure or depth. And if people write a symbol and give that file, you can use it. So those ones are like that, but they come with GMT. There are not many, but we have many others that you can download from the GMT servers place or something. One of them is really, someone draw all the dolphins and whales and things like that. And there is another one with geological symbols. And I'm not going to the front symbols where you can also draw your own or you program your own. So it's, again, a very large field of things you can spend your time. Oh, yeah, I'm in the cookbook. And on the cookbook, I see here, I search it for, well, this is Firefox. You search for custom symbols. And second or third, it depends, you start from the beginning, you have this list. So that one is the Flash. Did I run it? Did I? Yeah. Or maybe I did not run. See. That Flash. It's not exactly the same Flash because it's not filled. So fill this one with brown. Go ahead. Okay. This one is filled with color. This one is not. So how do we fill it with the color? No, the Scripps. Yeah, this one. Flash is the name. S is the symbol. K is the custom. Then comes the name of the symbol, and slash the size of the symbol. So, but if you want it painted in brown or whatever color you do paint it like we painted before the symbols. Not more complicated than that. So I want it in brown. What's the option for filling? Fill is minus G, capital G. So you do minus J, no, J, not J, G, brown. Okay, and it will be brown. Oh, quanto tempo é que eu passei? Quanto tempo é que eu tenho? This is the Flash. Doing the others. Okay. Just what do you have to change? The coordinates, if I want to replicate that, I have to put it in the different position so I do not overprint the previous one. I have to give it a different name, a different symbol, and paint it the way I want. And if I want to use the pen for the outline, I can do it as well. It's nothing new. What is new is symbols, custom symbols, you do it like that. All the rest, you just do it like you did before for the common symbols. Yes? It's called Mecha. Okay, but it's just a symbol. It's not a focal mechanism. Because no, the focal mechanism, Long is going to give you a full explanation of that. The focal mechanism, you have to give it the parameters of your solution. This one is a fixed thing. You don't change that. By the way, I don't know if you cannot have a rotation on the symbols. Yeah, you're going to use it tomorrow. Yeah, tomorrow. Tomorrow morning you're going to use it. Yeah, it's in. Where is it? Except this one is not a focal mechanism. with beach or with the strike slip, you don't change that. You cannot change anything. We don't have a way of, we have a way of rotating the symbols, but then you have to create the symbols with variables, and you can give parameters on your coordinates that say rotate me by symbol. You can't complicate this more. Because if you create your own symbols, because the symbols are a language. And you can make your own symbols because you follow the rules of that language, and you create a symbol that can adapt, extend for your coordinates, say rotate these into that position, scale it that way. You can do that. Or simple just saying draw a line to these points and these points, like those ones are there. The symbols in itself are a field of exploration. So doing the others, see, this one is gray. One I had in the example is blue. I would add -G blue, and I would get this. All the others is using different colors and different symbol names. Whatever. Yeah, these, the upper ones. The upper ones are different family of symbols. If you have okay, I don't know if I still have customers on the other side. No questions. But okay, these ones you can replicate these ones too. These are different type of symbols. You can have an encapsulated PostScript file with a whatever. And you can use that as a symbol. That's what they are. They are, this is the Sardinia, and this is one of the call. I made those symbols from PostScript, and I converted. So you can use these ones because they live. They live where? The GMT server Y, which is dead. It's up. Okay, so it will work. So it worked. So this one is just a symbol like the others, but you need to have its name in the word. It's a PostScript file that you can access, because for some files we store them in the server. It means if you use a particular syntax that Leo is going to explore much more for the grids, you can download. You just give the name, and it will download the file for you. So this one will be something like this. So of the coordinates of it, it's in here. So it's 1, x1, y5. 1, and the y is 5. And then it's called, yeah, you have to do this, know this, yellow. And yeah, this is the magic. And I think it's larger than 1.5. I think it's 3, but okay, the size, we'll try. And you don't paint it anymore, right? So if it works, we'll see. Again, K for custom symbol. The at means search in the GMT server to find this file. No, first search in your computer. If it does not find it, search in the GMT server. If it finds it, it downloads and will store it in your computer. So the next time we'll have it already. You don't need to download it every time. So if it is work, you will download this file. The file is called gallo.eps, but you don't put the extension. That's another thing from the PostScript custom symbols. So let's see. I think it's this. No. Well, I should have it in my computer because we use this file in the tests. There's one test. Oh, okay. Here it is. Let's see if it works for you. The terminal or the script? Yeah, it's very similar. Why we have these? If you know the file, it's on your. If you know that GMT will be able to find the file, you don't need the @ symbol. How can he find it? if it is on the current directory where you are running the scripts, or if you give it here the full path. All of them are equal. It's just this is the file name without the extension. If he finds it, and if it is a PostScript, encapsulated PostScript, then you will plot it. Means that you can make really any PostScript map. You have to convert it to encapsulated PostScript, and then you use that as a symbol. Of course, your file will grow. If you plot many of them, you risk to end up with very large files, but you can do it. This was a picture. This actually is the logo for olive oil, Portuguese olive oil, very known. That I like it. The one I took a picture. There was a place in the internet that could vectorize that, convert it into some other format that I converted into APS and put it there. The same as the sardine. You can do the sardine, but it's just the same. That would be the same. It's called Sardinia, I think, Sardinia. Coordinates is 4, 5, same thing. If I remember, there was a bit larger. Otherwise, something. And then the name, of course. You have to know the name. Sardinia. Okay. Yeah, we'll do the same thing. Just the same result. No. I left it in Portuguese way with it. That's the original name, so not sardine as you would say it in English. But this is a name, so you have to type it exactly the name of the file. So you should. No. Okay, I missed a bit. Oh, that's okay. I missed the coordinates, so I made it too large or things like that. So I'm not plotting them all because that's the idea. This actually a known sardine in Portugal was a famous. That one is a famous one. Okay. So yes, I got the hell off. Yeah. When you grill them, you don't do that. Only when you fry them, yeah, you might take the belly off. But if you grill them, you don't. Just put salt and grill them. Okay, so that goes for symbols. That goes for symbols now. We go back to them. The well, the general answer is yes, but I have no idea what they are, those symbols. Directly, probably not. Now, to plot symbols, you have this, either it is a custom symbol with that follow the rules of that language of the symbols, and they are called .def. You have them in GMT2C, you have the manual, or you can have a PostScript. You can have a picture. You can take your picture, you put your picture inside, wrap it into a PostScript file, and it will be a symbol. And you can plot yourself along the wall. But the other ones, they use, for sure, they use their own language. They would use an equivalent thing. So you do not plot with their syntax, which I do not know what it is. But you can convert. How much work is involved in that? I have no idea. But you can take a screen capture, wrap it into a PostScript, and put it there, and that would work. Perhaps the quality would not be so good, but so it's a yes, but the last one is building on, well, Paul already plotted Italy. Okay, this, okay. So I'll start a new Italy. A new Italy script. Start by doing this one. What is this one? whole plotted Italy, but the entire Italy. I don't, for this one, I did not want to have the islands, Sardine, or all that. So I just wanted to have a file that we could use as an example for applying again the lines and the filling, the fill of the closed line. So I use the country as an example, and we'll need to extract the boundaries of this part of Italy, which is not the entire Italy. It's only I only kept this one. So here I have to try a little bit, and I don't remember exactly. I have to consult my notes. So we'll start by doing this, but before that, we need to have the coordinates of that line. So it's Italy, but in fact, what I'm going to use as an example is we have a line with many points now. That's not only two, and we're going to plot the line, fill with colors, line an outline with a pen, and things like that. It is Italy, could have been anything else. But like this, because it comes with GMT, you can extract it and use and talk to you about the binary files. Because once before it was very small and we use text files. But when we have larger data sets, we don't want to use text files. They are too big. They take too much space, they are slow to load and all of that. And when things start to grow larger, you are interested in using binary files. So you're going to use this as an example of using also binary files. So I'm opening a new one. Nope. Nope. Insists. Now you already have one Italy. Okay, I'm going to call it Italy, so it's going to be different. GMT and show. Okay. But here I'm going to do it outside. I know, but this will have to believe me. Where is that? Paul already showed you how to plot the countries. So you remember in the inset, he made the inset, the sphere, the Earth, and then he plotted Italy in red. He extracted Italy from the coastline. We can use the coast command either for plotting or for dumping the data that's inside. You also can, instead of plotting, say, okay, give me the data, save me that part of the data in a different format. So, and here we found some feature that needs to be fixed. So I will do these outside of the GMT command. And I'll use, and I will write this PS coast. It's either this or that. I have to. So normally, when you are in modern mode, you don't call it PS coast. You just call it coast. But if I call it coast here, we'll have to give it the coordinates. And well, that's something that we have to fix for the next RC version of GMT. So I can, and to extract countries, if you still remember, it's the -E, capital E option. And then we put IT, it's Italy, right? But if I do this and I don't want to plot, I want to dump the data. So I'll use an option, if you try to see, look at the manual, there is an option called -M that means dump the data into the output, which is the screen, or redirect it to a file. So what I'm saying is output Italy to the data, not plot it, but okay, here and here I'm going to do one thing. Okay. I didn't find a better way. The manual for the other one is complicated, so this is a trick to extract only GMT converts, and I'm consult my notes. -C. All of this is in the manual, but you have to spend some time looking for it. Okay, I will tell you what it does. Okay, what it does, it says this plus L, it tells it will only save polygons that have more than 3,000 points. So I tried it with a couple of numbers because I only want the larger polygon. If you wanted to extract some island with these, you have to restrict with the region, would be more complicated. But like this, I managed to restrict the output to only the mainland of Italy. Because all the other polygons, because the file you have many polygons, each island is a polygon. Sabine is a polygon, the small islands are polygons, and each one has a different number of points, and they are smaller. This is the largest one. This is a trick. And to finish, minus B, O, F, okay? And the file, I'm telling about this. Yeah. No, but this is not the alias. You will work with the, I can put it, but oh yes, it's because of the things. Yes, more. Right. Okay. Do it this way. On Windows, yes, many times I don't need to put the GFT, so I forget. Okay, you type this. This thing, minus B, O, F. Minus B is the small cases options are global options, means they mean everything, sorry, they mean the same thing in whatever program they are used. The minus B means write binary or read binary. The O means output. So I could have minus B I, it means input, which we'll use after. So basically, it's saying write the file in binary with floats. Floats means each variable has 4 bytes, because by default, it uses double. But you don't need double to, you won't bring nothing except space and time. Because after the sixth decimal place is already the centimeter, something like that. And you don't have the precision of the data is 100 meters at the best. So float is more than enough. But because the default is double, if you want to use single floats, you have to put the F. So you say minus B for binary, O for output, F for float. And then I type the name Italia. Can put it .bin. The extension does not matter. Okay, if you put .bin, you will see. You will know. So this first command will extract Italy, the main body of Italy. And you write the outline of that polygon in the file called italia.bin. That file, you cannot see it with an editor. It's in binary. But now you can plot it. So we have it. So you'll do.
You don't have to have the Q or the
No, because in output you don't need, we'll have it in input. I'll go to that. In output you don't need to tell the number of columns because he already knows. But for input, yes. Although he assumes 2 or 3, but we are not using. So now we're going to do GMT plot, because here we're going to plot a polygon. The coordinates will do like minus, we need to specify the region exactly like Paul showed you in the morning. So you can put IT, yeah, IT, can do the plus R1, this to give the same example that they used in the morning, and can say it's Mercator, minus J, M. Now I don't put the units, I don't need. I can do the truth or not. So minus B, A, I'll let it do the automatic. Frame, the B is the frame, the G is the projection, the region of the map is, this is exactly the same thing that you have to do that Paul showed you in the morning. You have to say what to plot. It's the, you want to plot this one, Italia. Italia.me. But now the file is binary. And when the file is binary, you have to tell the program how to read it. Because if you don't tell it just, these are just bits for one of the others, you have to tell it the size of each one so it can decode it correctly. You don't have to do that when it's text files, so you don't use those things, but for binary files you do. And again, if you are using things that have megabytes, you don't want to use ASCII or text, because if it grows, you can go to the gigabytes without noticing. The first ones can be just big, but if you keep increasing, then the time to write these things you notice really on the processing. So big things, big files use binary. Or yeah, it continues even in binary. It grows to those sizes. So, but okay, you have to defend ourselves. But now we are reading a binary file. We have to tell it how it is, what's the format, how it is organized. So we use -b again, but now instead of O, we use I. And now we know that he has two columns because it's only X, Y. So I say 2, and then I say F again, like we had before. So I for the input, 2 the number of columns. If you want something X, Y, Z, you would put 3 in here. And then F to tell it that it's floats and not doubles. Paint it. That one was in light blue, I think. And thin dash it. I think that one was something like that. Oh yeah. Again. No. Okay. I didn't just call IT because of the others. So again, now not forgetting X exchange mode plus X. Mine is just called IT because I read another Italia. Okay. Right, let's see. Okay, a bit too large, but so this is a polygon that happens to have the same shape optically. Because we are not, you use the data from close command to extract it, but this is just a polygon. It means either the first point is equal to last, or you close it. And so you can put the outline, you can put the fill, and all the rest is like we had before. Oh, yeah.
Can I fill outside?
Can you?
Can I fill outside?
Yes, you can fill the outside with a minus plus G. Yeah, you can paint the background of your frame, of your map. This is a plot, so you where does it go? Minus B plus G. No G. Will it work like that, or do you have to give it more things? Let's see if it does, if it is enough. It's like this, but not 100% sure. Yeah. Because you can paint the background of your plots. This is not. Paul showed you similar figures with the coast command. The coast command has land and water. So you can paint the water the color you want. You can paint the land the color you want, the lakes inside land. You can paint it, but it's you are painting the earth. This one is not, it does not know what it is. It's plot, just plotting a polygon that happen to has these coordinates and this shape. So when you have a map like this, you can say, paint me the background with the color that you want. That's what I did here. Minus B plus is this modifier, plus G for fill, and then you give it the color or the pattern. So I use it that, well, lucky I knew the answer. You would have to extract the other countries because this is not painting countries. That's what I'm saying. Look, it just happened to have the same shape as Italy. It's a file with XY coordinates. So yes, if you had other files with polygons of the other countries, you could play with that. But you do that with the coast module, because you can say paint me this, and you can paint one with one color, the other one with other colors, and you overlap different countries. If, for example, if you want to put France in here, you would call it with coast, we'd call it one color with Italy, and the other France would have another color. And you would plot only the ones that you select. So for doing this with countries, you would use the coast model. Here I'm not using the coast model. I only use it to extract this polygon, so you can use it as an example, right? Oops. Close. Yeah. Closing. No, not this. Okay, I'll do this one too. Instead of painting with colors, you can use patterns. This is a pattern. Instead of saying paint light -G light blue, like I did, yeah, okay, I'm going to remove this one to make it smaller. I'm going to duplicate the line here the same. So here, this is the color. But we can use, GMT comes with the patterns. Pattern. Yeah, many things called pattern. Pattern, yeah. Where are they? They are further down. The list of patterns. Yeah, okay. Further down, see, it's a long one, the elevator is here. You have a figure with different patterns. The patterns, you have the number of the pattern, you use it with the number and the resolution. Okay, so did I one? What did I use? C32. I use it in that example 32, which is this one. So you have 32 is this one. You have the pattern and the negative. It means you turn the ones in zeros and the zeros in one. So you can have, it's separate. It's the same pattern, but you swap the black and white. And you do that using the small p, lowercase p, or uppercase p for that. So I'm going to use a pattern. P is for pattern. Now it's not the color. 1 minute, okay. Whew. Okay. Not the football, I will tell you. Okay. 32, and then I say the resolution are 100. Okay. The pattern number, the resolution in the dots per inch. If I make it 300, they will make it too small sometimes. It depends on the size of the video. This you experiment until you get what you want. So, but Paul is going to make a movie with my last example. So. See, I have the pattern. So you can fill it with colors or with patterns. The pattern can be a JPEG figure. You can take a picture, and instead of using this, you can make any figure as a pattern, and you will repeat that pattern inside the polygon that you are plotting. So here as well, you can make many different ways of filling a polygon. Again, it's the minus G and the patterns for that. Okay, so they are saying I have no more time. Oh. Yeah, but yeah, we have the project for tomorrow or something. Yeah, we have not that. It's still a little bit open, the projects, because I wanted you to try to do the last one. So this one has the patterns, as a symbol, which happened to be a custom symbol, but not one. You have, it's the same symbol, but you plot it more than one. You have 1, 2, 3, 4, 5. So you have 5 coordinates. So you have the symbols, and underline there is a line, which happens to be dashed. That makes this. So it would be the conclusion of these series of examples. You plot the polygon with the fill. You plot symbols, not one but a couple, and a line with a certain structure. Yeah, well, they have it. They have this. They have this on the shared folder. So let's say the exercise for you is do this. This is the make symbol. We saw it already to plot one. What do we have to do? The coordinates are simple. I made round numbers on this. So you have to create a file with 5 points, which is this, or some other. It does not need to be exactly this one. And plot the dashed line. You plot the dashed line first, and then you put the symbols. Otherwise, the dashed line will be on top of the symbols. It's not so nice. So first you plot the line, and then you plot the symbols. So, and okay, you can turn this into blue, you read the manual, or leave it in black and white like this. So this would be the exercise that you can finish.
Just want to say a few things about custom symbols. So if you want to get deep into this stuff, we could have a whole workshop on custom symbols. I encourage you to read the appendix on custom symbols. You'll see that there's a programming language built in. You can have if tests. You can read optional input data to have your symbols change direction, size, color, what kind of symbol it is based on data. So if you like to tinker with code, you can make a really cool custom symbol that can read your data and behave differently. So it's like the sky is the limit there. It's very complicated, but spend the time to read it once at least so you're aware of this when you need it.
We have a user that helps us that makes really beautiful maps. That they have a company that navigation charts for long flights. That with all those symbols and the distance between airports, their maps is really complicated. If I had to do one of these, I don't know how long I would spend to do it. Very professional maps with custom symbols. You can do a lot of
So they have the dragon and the serpents that you put out.
Oh yes, they don't, but I do. Yeah. Of course, I forgot about this one. There is something with this PostScript. I cannot convert it because I lose things. So, yeah. If I zoom, okay, it's in PostScript in this one. Okay. So you want dragons? I have whales. Yes, dragons. Yeah, I have dragons. Dragons, Vikings, sardines, cows. Yeah, octopus, whales, tuna fish, lobsters. Yeah, dragons there. There's a dragon.
We don't have any data in the ocean.
Yes, you put dragons. Yes. What is this? Just like symbols like this, you'd say plot it that position with that size, and you get this. Breakdown. Okay. For this one? This? P for pattern, number for the code. You have to consult that table or experiment with the others and play a little bit with this. It depends on the size. You can put here 300, but it would be small. This is the resolution of the symbol. I could put capital P, it would make the negative.
32 was the pattern.
32 is the code of the pattern. You have to consult that figure with a can put the breaks and things. So you look at that figure, there's the number, and if you want to replicate that, you use that one.
Oh, you're gonna want to use.
These ones not, but the ones you can program, yes, you can program to accept an angle. Now that's what Paul is saying. There is a whole programming language on that. You can, then you would have to program it to accept the parameter, which is the angle, and then you would rotate the angle. These ones are fixed size, fixed orientation, not fixed size. The size change. The sardine, you cannot change, rotate the sardine. No. Then you need to read more, because the symbols have a programming language, and you can have the symbols written in such a way that they expect an angle. See, if you have a line, that line could expect not only the length but also the angle, and then you would give it with the coordinates of the line plus the angle, and then you could rotate them. But these ones are more static. You do not rotate them. That's what I was saying, because you should be able to rotate the symbols with an option, with some extra flag, and say rotate this custom symbol. But not now that I'm aware of more than that. Okay, so yeah.
Can you show the code, please?
So for the online people, the plot you're going to be recreating is this one here. Okay, so going to my terminal, I have here in the short course directory, I have nothing inside this, so I'm going to type ls, and there's going to be nothing in there, but you will probably have something in there already. Now, Joaquin used that @gallo symbol. So where is that coming from, right? So when you have an @ symbol, what GMT does is it's first going to check on your computer on some specified directories if that file called gallo.eps is in there. If it's not there, what GMT is going to do is look in the GMT server in Hawaii and find that file, download it to your computer, and save it to that directory. Now, the next time you run it, since the file is already on your computer, it's not going to download it again. It's just going to go and use that file that is in your local computer. Okay? Now, where are those files located? So there's a command in GMT that can tell us this, right? The command is gmt which. So if I type in my terminal gmt space which, and I give it the file name, so I want to know where gallo is. So if I run this, right, because I don't have it, because I wasn't running Joaquin's examples. Okay, so ignore what I'm going to run next. Okay, now pretend nothing happened. Okay, so gmt which @gallo. Let me get this out of the way. And when I run that, yeah, .eps, sorry, .eps. So you see, we're all very new to this. So for some reason, I have to do this. Oop. Okay, that should not be the case, though. Okay, so the actual command, now that we've learned something, is gmt which @gallo.eps. I don't think we need the .eps, though. -gu. And we'll go over what that means later. But if we type this, then it tells us where the file is located. So for me, it's in home leo.gmt cache. But for you, it's going to be something different depending on where your home directory is. All right, so if we if you navigate to this directory, you're going to find the gallo.eps file in there, and you can open it. So it's not a magical thing, the @ symbol. So this is just a shorthand in GMT, and it'll search your computer for that file. But that's an actual file that exists in your computer. Okay? Yeah. Okay, so now we've seen that Gallo file, but that's useful for plotting, but not for analyzing data. So let's look at a data file, for example. So one data file that GMT offers is a bunch of gridded topography. So GMT has a module called GRD info that gives us information about a grid file. Okay, so if we ask for the special file, if we ask for the info on the special file at earth_relief_, in this case, 60 arc minutes. So this is going to be a gridded earth relief file in 1 degree grid spacing. So if we type that, okay, this is kind of big. Okay, can you see this? That looks kind of ugly, but let me make this full screen. Okay. All right, so if we type that, what GMT is going to do first is it's going to go and check your computer if you have this earth relief 60-minute file. If you don't have, it's going to download it from the server, put it on your computer, and oh, it's not showing again. Where was that? No, I was sharing the desktop, but it disappeared for some reason.
I sort of missed the point about the Jolla. What is that?
That's the file that Joaquin was plotting, that rooster.
Oh, okay.
Yeah.
Well, why is it? It doesn't have much to do with that.
Where do I open that? Here we go. Share screen. Back to meeting.
Yeah, try that. It's not working?
No. So why do I have the chat? Oh, here we go. It's here. Share. It says that someone else is sharing the screen. Yeah.
Oh.
Yeah. Oh, wait. So someone else is sharing the screen.
Oh, yes.
No. Yeah. I think it's Mohammad Reza. Is that how I pronounce your name? Sorry if you're mangling it, but I think you're sharing your screen. Yeah, could you please unshare? I don't know if we can overwrite. Oh, okay, there you go.
Okay.
Thank you. Okay. Okay, now we're good. Right, so forget the Gallo thing. That was just to show where things live on your computer.
Okay.
Yeah. Now, so we ask for the information on this 60 arc minute earth relief grid file that GMT distributes. And what GRD info is telling us, I'll make this full screen. It's telling us that this is a 60 arc minute earth relief grid. The command that was run to generate this file was GRD filter, blah, blah, blah. There's a remark here added by Paul probably that this was obtained by Gaussian filtering with 111 kilometer full width filter from Earth relief 1 minute. So there's provenance information in the grid. So it contains information about where this came from and how it was made. It also tells us the format of this grid file. And the format that it says here is netcdf. The netcdf is it's a very popular gridded data format, especially in ocean and atmospheric sciences. And GMT uses this because you can contain a whole bunch of information inside of a single file. In our case, it has not only the topography information, it has coordinates, it has metadata about where this file came from, how it was made, and also what's the coordinate extent, what's the Z range, so what's the range of values inside it, and a bunch of other things. You can even contain information about the projection that was used and all that. Right, so GMT relies on this netcdf data format. So when you hear about a GMT grid, that's usually actually a netcdf grid, which can be opened in other software as well. So you can open it in Python and other languages. Okay, so now that we've seen the information about this file, so how would I check where it's located in my computer? GMT space which at Earth relief 60M. Yeah, I really do need the -GU, sorry. So it's in the same, it's not in the same directory, but it's close, right? So it's in the gmt/earthrelief.grd. So this is the file. So if you want to open this file on your computer, instead of using the @ symbol, you can go to that directory and copy this file around. Okay? And so let's go back here.
How does it know what the suffix is?
I think it knows that every Earth relief thing is going to be .grd.
Okay, but the other Jolla was an EPS.
Yeah.
The default is special.
Okay. And the symbols need to be APS. So the custom
Yeah.
symbol either it is a .def file or a .eps file.
Yes.
If you move something on a mask, and I'm going to do this drag and drop, will that change, like, will it give you errors in the terminal when you're looking for it?
If you move what?
You don't need it.
Like
Just
the
like
script?
I meant move the short course folder to my desktop or something. Or like, if I moved one of the files in short course to my desktop, would it still be able to find it and access it?
Okay, so for the online people, the question was if you move something like using your file navigator, if you move it, how do you find it again with the terminal? So the terminal isn't using a special file system. It's the exact same thing that's being shown on the file navigator. So if you move something around, it moved around when you're navigating in the terminal as well. So if you move the entire folder and now your terminal is giving you weird errors, close it and open a new one. That's usually the easiest way. Okay, so GMT grids are netcdf grids. This is a blurb from the Wikipedia entry for netcdf. So it's a self-describing format, yada, yada, right? So, okay, so we have this grid file. Yep.
What would happen if this grid file wasn't here but was on a remote?
What do you mean?
Like, this is in the distribution. What if it was a giant grid file somewhere else?
Oh, okay. So the question was, what if the file wasn't on your computer? So this grid file was not on your computer until you ran GRD-info. So when you run GRD-info, it first checked on your computer to see if the file was there. If it wasn't, it downloaded it. And if we want to know how large that file is, the Unix command for doing that is du. So we can do du and copy and paste this. So that's going to tell us the size. And this is a 112 kilobyte file. So that's why it was instantaneous to download. And that's also one of the advantages of NetCDF is because it generates small files, because it does compression and all sorts of things. Now, if we were to ask for the 15 arc-second grid, that would be a big 2 GB download.
What about the 1 minute? I asked for it.
The 1 minute is also pretty quick. So if we want to do the 1 minute grid file, instead of doing 60 here, we can do 0.1. Oh yeah, so the resolution here always has 2 numbers. So if you want a 5 arc minute resolution, it would be 0.5. But 0.1 is going to work as well. And for me, it was instantaneous because I already have it on my computer, but it might take a little while because this is a few megabytes now. Right, so the only thing that's going to change is how long you're going to sit here waiting for this thing to download on the public Wi-Fi that we're on. Right, so I'll skip the slides here. Okay, so now that we have a grid, let's try to plot this, right? And one of the ways that we can plot gridded data is with contours. So we're going to draw, well, I'm assuming everyone knows what contours are. Is that correct? Feel free to ask if you have any questions.
Go ahead and explain again.
So contours are lines that have the same value. Okay. Okay, so let's open Visual Studio Code. I'm going to create a new file here in my short course directory, and I'm going to call this contour.sh. And we're going to do the same process we've been doing so far, which is the hash. Can everyone see this, or is the font too small? So /user/bin, no, was that it? Okay, /bin/env bash. And the same format we've always been done. So GMT begin, contour, and we'll let it choose the format, GMT and show. And in between here, so first thing we got to do is let's create this contour map, right? So we can do GMT, and the command for doing contours is grd contour. The only thing that's actually required now is if we give it the file name. So we're going to use our Earth Relief file name, which in this case is a special remote file. So we start it with @Earth Relief 60 minutes, and that should be it. So let's save this and try to run it. So let's do change mod +x to contour. Yeah, contour.sh. And now let's try running. So /contour.sh. And let's see if we're going to get an error. Oh, okay. So we got a map with all the defaults, right? So it's kind of noisy, but it kind of works. The default projection is I'm guessing Mercator. No, it can't be Mercator, right? So yeah, so it's not a good projection. Like, things are very stretched. We can do better. And the default contours, notice that there are 2 types of contours. Some of them have there are thicker lines with the numbers, and some are thinner lines with no numbers. Okay, so GMT has these 2 things that are set separately. So you can separate contours with numbers or without numbers. So this is an easy thing to set in GMT, which most other plotting packages make it a little bit harder. Okay. All right, so let's try to make this a little bit better. So what could I do to make this better? I could change the projection. So what projection do we use? Any suggestions? Let's do Robinson. So Robinson is R, and you do not have to remember this. If you don't remember the projections, we go to, I'm going to close this. So if you don't remember the projections, we go to the GMT docs, and there's one of the first things here is GMT minus J codes. So you open this up, and these are all the projections and their options available in GMT. So if we want to do Robinson, we can search for Robin, and oh, it's actually N. Yeah. So see, our memory was wrong. So Robinson is not really R. Robinson is N. So it's N, and we can optionally give it a longitude, but we're not going to do that. So it's not R, it's N. And what else do we have to specify in minus J? The width of the plot. So let's make this, what size were we using before? 15 centimeters, okay. So let's save this and run. And remember, on the terminal, if you press up, it'll repeat the previous command. Okay, so that's a lot better now. What else can I do to improve this plot? Oh. I could scale the numbers. What else is something that's obviously missing here? A frame or a border, right? And how do I add a border?
Minus BA.
And we can leave it with the defaults, okay? So just minus B. So let's see what just minus B gives us. Okay, and now we at least have the numbers here showing longitude and latitude with a nice frame. Okay, so all these improvements you've seen before, and we're reiterating. So is there anything else that we could do with the things that you've already learned to make this plot a little better? Colors? Well, we'll have to go into a bit more on that, but let's do colors then. Okay, so we have the contour here. So how would we do colors? Minus G. So what was minus G when you were doing plot or coast? It was fill. So do we want to fill the contours? Oh, we could, but let's not. So if we want to change the color of the contours themselves, how do you think that would be done? With W, because the contours, they are lines, like the lines you were plotting with Joaquin, right? So if we do minus W, that will change the pen of the contours, right? So, well, did you want to make it red for some reason? Let's see. Olive drab 4. Yeah, go nuts on the color. Right, so all the pen options that Joaquin talked about, all of those will work with the contours. So you can do dashes, you can do the line thickness with the same exact options. So you can say thin or thick, you can give it 6 points, or you can do dashes with the same syntax. What happened here? Okay. All right, so unlike Paul, I don't like the long lines, so I'm going to do the break here. Sorry, I forgot what I was going to do next. Whoa. What's on?
And there is no GMT option to change the color.
Yeah, I don't know what happened, so I'm going to close. And I'm going to open a new one. And hopefully it did not go away. Okay. So I have a green terminal now, apparently. So let's just work with that. That might be the plug here, actually. No, why did I mess with something that was just green?
We have a crane. I have a crane on the shell.
Is it green on the? Yeah, but why is it not working now? Who decided that using Linux was a good idea?
Linus.
Nothing. What? Oh yeah, that is a Python package called PyJokes, and yeah, it'll print a random joke every time you run it, and I have it set to run every time I open a terminal. Yeah. See, I waste my time in that instead of buying a better computer, and now I can't. Oh, there we go. Okay. No touching things anymore. Okay. Let me pull up my cheat. Okay. Okay, so one other thing we can do that Paul and Joachim didn't talk about, one thing you've seen here is that we can set the projection and the frame and the region directly in almost any command that does plotting. But there's another GMT module called basemap that just does that. So it's just going to draw the frame around it, right? So one thing I usually like to do with basemap, because then if I change the contours around, the order doesn't matter if you have multiple commands. But just for the sake of completeness, one thing we can do is GMT basemap, and instead of specifying the projection and the -b here, we can put it up here. The one disadvantage is that we need to tell it the region now. So with -r, and how do I say plot the whole globe? G. So now I have a shorter line and I don't need the line break. Okay, so this should work exactly the same. So if I do contour.sh, I get the same plot, right? So you can keep it all in one line, or you can break it up with basemap. That doesn't matter too much. That's a preference. Okay, so now we have a somewhat decent, yeah?
Didn't plot the shoreline.
No, yeah, we didn't plot shorelines. Huh? Plot, yeah, basemap just plots the frame. So if we remove the GRD contour and run this again, then we'll see that basemap draws the frame and nothing else. Right, so you can separate the frame drawing if you want, or you can put it into your plotting command. Okay. So another thing that's not so good about this plot is that it's kind of hard to see all these contours, right? So one thing we can specify is the contour interval. So how close are all these going to be? And in this case here, we have lines with the numbers every 2,000 meters. And we have the lines with no numbers, I'm guessing every 1,000. It's kind of hard to know. Yeah, but we can set this, okay? So again, if we don't remember how to do that, how do we check the docs for GRD contour? GMT docs, GRD contour. So that should open up our browser window to the GRD contour documentation. And one of the arguments that we're looking for here is -c contours. So this the contours that may be drawn specified in one of four possible ways. So it's a very long options. You can specify manually which contours you want to do. But if we look at the last option, contours is interpreted as a constant contour interval. So what that means is that minus C and an interval is going to use that interval in the data units. So if we want to plot contours every 2,000 meters instead of every 1,000, how would we do that? Minus C, 1,000. Okay, so let's save and run it again. Okay, so now we have contours every 1,000 meters, but what happened as well? Now we got no numbers, right? So if we don't say anything, it'll do the default. It'll plot the no number contours and the numbered contours. But as soon as we change anything, then we have to specify almost everything, right? So now it doesn't have the numbered contours. So how do I specify numbered contours? So we go back to the documentation. And the first option here, so it's minus A, and it says that contours is the annotation interval in data units. So with minus A, we can tell it what's the interval that we want annotations. So if we want to have, so now I got to break this line again. If we want contours every 1,000 and every 4,000 meters, we want an annotation. So how would I do that? Minus A, 4,000. So save and run. Okay, so now we have annotations every 4,000 meters. Okay, so, but notice that before the annotated contours were thicker than the other ones. Right, so there must be a way to specify the pen for the annotated contours separately from the pen of the normal contours, because GMT did that, so somehow there must be a way to do it. Now, if we go to the docs here for minus W, right, we'll see that minus W here, you can specify the type. So if present, it can be A for annotated contours or C for regular contours. So if you add A or C to the minus W, you'll be specifying the pen for the annotated contours or for the normal contours. Okay? Right, so if instead of minus W red, how would I plot if I want red annotated contours and black regular contours? So first, how do I do the red annotated contours only? Minus W red, but what's missing here? A. Okay, so the A here is this type that we see in the docs. Okay? So this is going to draw red annotated contours, and we can check that by running the script. All right, so now we have the default for the regular contours and red annotated contours. And how do I change then the regular contours? Minus W, C, and I can do blue, for example. And run. Okay, so we can specify them both separately. Now, this is not, I'm not saying you should draw plots, contour plots like this, right? So a better way would be to replicate what GMT was already doing, which was the thin black normal contours and thicker black annotated contours. So how would I do that? So how do I make a thin black regular contour? Thin, comma, In this case, I want black. Okay? So if I do this, I'm going to have thin annotated, regular contours. But thin is not actually very thin. Right? There's actually things that are thinner than thin. So we have thin, we have thinner, and we have thinnest. So if I do the thinnest possible contours, then I'm going to get a very, very thin line. Okay? If you want thinner than this, you can also specify the number of points, so like 1p or so on. Okay, so how would I plot a thick black line for the annotated contours? Thin black. Okay? Okay, so now we sort of recreated the default, but we can control now the line spacing and all that we want. Okay? Another thing that we might want to control is the size of these numbers. Right? So if for this size plot, these might be too big. So how would we control that? So all that is specified in -a. So if we were back at the docs, -a is a very, very long option, right? So it has a bunch of stuff that you can add to it. So you can specify the angle of the annotations. You can specify like drawing a frame around them with colors or all sorts of things. But one thing that we can specify is the pen for the annotation with the +p here. Oh, no, sorry, outline of text boxes. No. Which one was it? F here, sorry. With +F, we can specify the font, and in particularly the font size. So if in -a here, if we give it +F, and let's say like 6 points font, now we're going to have a smaller font when we run GRD contour, run the contour script. So now we have much smaller annotations here. Okay? And there are many, many configurations for GRD contour that you could do. You can specify like removing certain small loops to make the plot look prettier. You can smooth out the contour lines. And as with almost anything in GMT, the configuration options are limitless, or they're only bounded by the amount of time you're willing to put into customizing your script. You could spend a whole year customizing this. I don't recommend it if you have a thesis due soon. And in general, the defaults are pretty good.
So the default is like annotation font primary or something like that.
Yeah.
There is one is interesting, I don't remember. Perhaps let's see or something. It's make curved lanes.
Oh, yeah.
There is one.
Yeah.
Let's see.
So there are so many options that not even the people who developed them remember all of them.
There is one. I'm looking at that 4,000.
This one?
Yes.
Yeah.
It look nice. You would go round, not perfect, but there is one option that to make the label follow the curve instead of just putting a,
yeah. So you can do
then you
many
have to
things.
at least find which one speed.
Okay, so one other command that we need to talk about with grids is, let's say I don't want to plot the entire, I don't want the entire grid, right? So let's say that I just want to plot Mexico. So how would I do that? So when in doubt about the country code, one thing you can do is Google ISO country codes. So if you do that, there should be a Wikipedia entry. And this is going to give us a list of all the country names with the emoji flags and the two-letter. Oh, this is not. Oh, yeah, here we go. Right, so this page is going to have the country name and the two-letter country code. So if you want to know the country code for Mexico, it's MX. Okay? So let's plot Mexico. How would we do just a contour plot for Mexico? Minus R, MX, right? And that should suffice. So let's run again. And now instead of having the entire globe, we have just Mexico. Okay? And one thing that you could notice now is that the contours, they don't look very smooth, right? They're very jaggedy. And that's because our data set is only it's 1 degree grid spacing. So it's a very coarse data set. So it's not going to look good even if you contour it. If you want to do a higher resolution one, I would not recommend going like full 15 arcsecond now, unless you're willing to wait for a 2 GB download. But we can go as far as, for example, 10 arc minutes. That should be fast to download. Okay? So if we do that, then we get a better grid here. Does everyone get this plot? Okay. So now I'm going to give you 10 minutes and, oh, sorry, one last thing that we can do. So let's say I just want to plot the land. If I don't want to plot the contours in the ocean. Okay, so that's the Robinson projection. So you're kind of seeing, remember the oval shaped map? So that's just the bottom of it.
Okay. So I want to choose one that is on.
Yeah. So try the one that's a capital G. Maybe it's
How do you know? What's the latitude and longitude for like the center? It's like 0.
Yeah. So if you're in the South Pole, does the longitude matter? No. And what's the latitude would be?
0.
So 0 is the equator.
Yeah, so it's negative 90.
Negative 90, yeah.
I'm close, but I have to look at the
Yeah, it's not cheating if you look at the docs, because, yeah.
What's the latitude? Minus 60, yeah.
I don't remember, because I was using the country code for Antarctica.
Oh, okay.
Yeah, so you can do that and add some padding of a couple of degrees. Yeah, that works as well.
Maybe 55.
I'm using this one with GAGE. So there's no hole there. So it must not be that protection.
Which one?
The GAGE one.
Okay. And you just set minus R or something?
I think it's you must have a something that's like maybe like
No, that should be the minus R. So try setting the numbers manually.
You
set
have
the minus R.
It's going to be recorded.
And setting the west east boundaries from the numbers.
It's just
That would be plus.
no, he did it with I don't know how he did it.
Right, so you can specify the country code, but you can also give it for numbers. So it should be west, east, south, north. So for west and east, since we're doing a full circle, so you could do 0, 3, 6. Or minus 180, 180.
right 0
doesn't work to get the region.
Yeah.
Yes, it's here.
Yeah. So yeah, that's actually a bug. Yeah, so that's actually a bug. So you can't. Apparently lately the Antarctica. If you use the Antarctica code, it's not going to work. It's going to cut out the South Pole. So if you're getting a donut instead of a dish, then specify the region with numbers. So west, east, south, north.
Wait, so R and then
west/east/south/north. And that should work. And in case you're wondering, the north boundary, if you go to -60 or -50, that will give you something close to this. So for west and east, right? So we're doing a full circle. So you could do -180 to +180, or you could do 0 to 360. And for the latitude, what's the latitude at the South Pole? -90. And if you want to catch all these, if you go to -60, that will usually get you the entire continent. Okay. Any luck? Ooh, okay. Okay, so there has been mixed success, but for the sake of time, let's do the solution together here. So I'm going to create a new file. I'm going to call it Antarctica.sh. The file here is wrong, but okay. Right, so same thing as always, /user/bin/env bash gmt begin. Ooh, my name here is wrong. Yes. Okay, gmt begin, Antarctica, gmt and show. Right, so let's set the base map first, because I like doing that. So what's the region that we're going to plot? So the west side is going to be 0, and the east side is going to be 360, because we want to do a full loop around. And for the latitude, we're going to start at the South Pole, and we're going to go until -60. Okay. The projection that I'm going to use is the uppercase G, which is, I forget the name. Paul, does anyone remember the name of uppercase G? As in orthographic, yes. Right. Hmm? Yeah. Well, let's just do this. So for this projection, we got to tell it where to center the globe, or the projection point. So we're going to put it at the South Pole. The longitude doesn't matter. And -90 for the South Pole. And we're going to make this our standard 15-centimeter plot. Okay, and I'm going to draw automatic boundaries around it. -b. Now, to draw the contours, I'm going to do GRD contour and at Earth relief 60 minutes. What else do I need? Well, before that, let's check if this is working. So let's run chmod +x Antarctica and // Antarctica. So let's check if our region at least is correct. Okay, so it's almost there. So we got the region right. Now we want to plot just the, let's plot just the positive contours with black, right? So how do I limit the contours to be just positive? -L. And I can give it a range, or I can say P. So P means just the positives. And so if I want 0 included, I have to do uppercase P. So lowercase p means no 0. So we're going to leave 0 out for this case. Because who cares about the short lines? It's not like they matter about it. Okay, so we're going to plot just the positive ones. So if I run this, I get just the positive contours. Okay? Now, I'm going to plot them as black. Or they're already black, so I'll leave them as is. Okay, so how would I plot the negative contours in blue? I can copy this GRD contour at earth relief 60 meters, 60 m. How do I tell it to do the negative contours now? Minus ln. And how do I tell it to plot these in blue? Minus w blue. Okay? So if I run this again, now you get the blue and the black contours. And what if I want the shoreline, which would be the 0 contour? What if I want to plot that as well? How do I plot shorelines? GMT coast. And anyone remember the argument for drawing the shoreline instead of coloring? Ooh, almost. Minus W. Right? To draw the shorelines, yeah, of course. Right, so minus W is going to plot the shoreline. So if we run this, you get, huh? Some of the contours? Oh, you mean like here? Where? Like here? Yeah, so I'm guessing this is mostly a resolution thing. Because remember that our topography grid is very, very smooth. Right, so it's not going to contain these tiny little details. Right, so if I want to make this shoreline thicker, I could do minus W thick. And this is kind of halfway there, right? But you could mess around with the intervals and things like that. So this is a quick way to plot two things at once. All right, so moving on. Until what time? How long do I have, actually? Ooh, okay, so we got to be quick now. Okay, so let's create a new file. Now we've plotted all these contours, and you can play around with the pen attributes the same way we did with the plots, right? But what if you want to plot this as a colored image? So again, let's do our usual dance of the user bin m bash gmt begin, and I'm going to call this image gmt and show. And I'm going to call this script image.sh. Right, so if we copy over the same thing, so let's say we want to make the same Antarctica plot. Or, yeah, okay, let's do this. So we got the same region here for Antarctica. But what if we want to plot that using colors? So to do that, the command is not GRD contour anymore. Now it's GRD image. And the same thing with GRD contour, if we give it the grid file, earth relief 60M, it's going to give us the default plot. And if we want to look at that, we can do chmod plus x image.sh. And then /image.sh. And we get here our color image plot. Now, this looks kind of bad because we're doing 1 degree cells. Right? So we could use a more higher resolution image, but as Paul said, this is quick to plot. So get this working first, and then you run it again with a higher resolution. It's going to be the exact same command. Right, so now instead of having the contours showing us values, we have the contours, the values mapped to specific colors. And what we don't know is what these values are. So just from looking at the image, there's no way for us to tell what does this white here mean. To do that, we need to plot a color bar, which would be a bar that shows us the mapping between the numbers and their associated colors.
Why does it show higher resolution closer to the pole?
What do you? Oh yeah, yeah. So it's yeah. So yeah, when we project, see that they are kind of squared. Yeah. Right. So how would I plot a color bar? Any guesses? That's the old GMT. No, so the new name for plotting a color bar is GMT color bar. Okay. Now I don't remember if color bar has a lot of default arguments. Does it work with no arguments? No, right? Yeah. Well, let's try it. It's probably not going to work, but yeah. So when you get an error message, look at what it says, and it'll tell you which command is generating the error. So for us, it's saying PS scale. So I'm guessing you need like a old GMT translation dictionary. So PS scale is what color bar used to be called. So yeah, we should also work on that. So it's saying that -D is required and must be specified. So we need to specify an option called -D. Now, if we go to GMT docs color bar, it's gonna open the browser here. And we're gonna see that -D is also a huge, huge option with many different configurations. Exactly. So this is gonna be probably a lot simpler in GMT 7 or 8 in about 10 years time. But for now, this is a somewhat complicated thing because -D controls where you're gonna put the color bar and how big it's gonna be. And luckily, we've seen some of this in when you were doing the inset. All right, so the one thing we can do is we can tell it to do a relative position to those 4 corners of the, or those 9 corners of the figure that Paul was talking about, like so top right, top left, and so on. So with -D, we can say J for let's use these corners, but on the outside. So we don't want to plot the color bar inside of the map. And let's say we want it at the bottom center. Okay. Now let's see if this is enough. Oh, I don't want GMT docs. I want to run image.sh. All right, so just with those defaults, we get this, which is a little bit of a mess because it is plotting the color bar at the bottom center of the figure just as we want it. It has the values mapped to the colors, but the problem is that it's printing way too many values here. Okay? Now, any guesses as to how we can control what gets plotted, the numbers here that are plotted in the color bar? Not quite. So how do we control what happens in the border of the map? -B, right? So remember, -B draws the border of the map, and it's the same command that draws the borders of the color bar. So you can think of the color bar as a mini inset map that was drawn here. Okay? So what we want to specify is -B to specify the labels of the color bar, right? So the border of the color bar. And one of the arguments we can give it is the interval that we wanted to put the ticks. So let's say we want a tick every 1,000 meters. Okay. Red sticker. So if we do that, now we can actually read the numbers, right? Yes. Yeah, minus B 1,000 in the PS in the GMT color bar command. Yep. So you have the exact same. Ooh. Okay, so for those who worked, right, so there are many things that you can do to configure the placement of the color bar. Another thing that we can specify, oh, sorry, a lot of people having trouble. I'm gonna have to send it. Yeah. Oh, so you just hate. So if you take away the minus, you can work. Or oh yeah, you also even without this. But no, B. Yeah. But I'm so curious about this. And if you remove the color bar, it works. Yeah. Okay. Is everyone getting the color bar command? The script just hangs and doesn't do anything? Yeah.
Yes, it's just hanging.
It needs a what? Here?
Plotting thousands of little things.
I think it's
Sometimes when it looks that you look at your slides and you cannot consider even.
Yeah.
But it might be writing
Thousands of ticks. Okay. So for the online people might be having the same trouble where when you run this, the command just hangs. If you want to kill a command in Bash, you type Control-C, and that will kill the command. So if it's running forever, Control-C will kill it. So how does it work?
just, I think it's only been fixed after RC3 came out.
Ooh,
So
okay.
minus capital C blank.
Minus C, like this?
Yeah.
Okay. So please try putting minus capital C, and let's see if this worked for everyone. Okay. Does that work? Okay. So good. So yeah, we have tons of bugs. Yeah.
When I saw the GRD contour,
So just contour will expect points instead of a grid. So yeah, so contour exists and there's GRD contour. The difference is that GRD contour expects a grid and it'll draw contours from a grid. But if you have just random points laid out through your study area, contour will take those points in. So the input is not going to be a grid, it's going to be something like the input that you provide to plot. And so X, Y, and the value. Yeah? Okay, so the question was, what's the B1000? So minus B always sets the frame of whatever we're plotting. So in this case, it's the frame of the color bar. And the number you give to minus B is the interval between the annotations. So if if you give minus b some number as well outside of the color bar, it'll also set the annotation interval. Yep. And for some reason, we need minus c because this is a bug that we're gonna fix probably later this week. Oh yeah, yeah. Okay, so it's already fixed. It just hasn't been released yet. Okay. Now, one other thing we might want to configure with these maps is what kind of mapping do we want between the numbers and the colors. So the automatic thing that GMT is giving us for the earth relief is this this color map called Geo, which you can tell that it's not linear. So it's going from blue to white in the oceans, and then it's all sorts of weird colors in the land. And this is, it's only configured this way to make things look pretty, okay? But there are many other color maps that you can use in GMT. The way to find them is a little bit tricky. So if we're in the GMT docs, we have to go to all the way at the bottom. There's the cookbook. Cookbook? Cookbook, yes. And then colors. Yeah. So I think it's of colors and color legends. Yeah. And there, see, here you have a list of a bunch of names of these color palette tables, or CPTs as they're called in GMT, and a plot of what they actually look like. So this is Geo, the one that we were using. Okay. But let's say we want to use another one. Let's say we want to do like some cool sounding one, like Abyss, you know, to make it more dramatic. So how do we tell GMT to, instead of using Geo, using Abyss? So here in GRD image, that's specified with the -c command. And we can give it the name of this color map. So let's do Abyss. And save. And if we run this again, now we get a different color map here. So we have Abyss that goes from deep dark blue to a light bluish color. Okay? Right, so I think that's all the time we have for now. But there's a bunch more that you can do with this, with the color bar placement. It's the same syntax as for the inset placement. So you can control top right or bottom left or middle center. You can make the color bar vertical instead of horizontal. What else? Yeah, so a bunch of stuff that you can do with this. One final thing that I want to do, because it's quite simple, is if we want this this color to pretend like there's a light shining on it, so there's shadows behind mountains, the only thing you need to do is add minus I to GRD image, and that will give you an automatic solution that is usually very good. So if we do that, now we see that there's some shadow here, but this is a pretty bad data set. So I'm going to run it with a higher resolution one. Let's do 0.5. So it's going to take a while longer because it's trying to plot a much larger grid. But now we have a nice image here of Antarctica, and see that there's shadows behind mountains. Right? I added minus I to GRD image. Oh, okay, sorry. So for that, I changed Earth Relief 60M to 0.5M. But you might want to do 10M or something like that. Yes. Wow. So the way that this works is you take a derivative of the grid and use that to calculate the shadows. So minus I, before you had to do this by hand, but now with minus I, it does it automatically. Yeah. Ooh, yeah. So plus Z. Okay. So don't use just minus I, do minus I plus Z. Oh, D. Okay. So, and this will give you the default gradient.
Default means angle
45 degrees. Yeah. All right. So if we do that, we will get the default, which looks the same. Yeah.
Then how can I
Invert the color bar. So for that, we would have to do make CPT. So we didn't have time to get through that, but we can work on that later. So you can do things like invert the color bar and mix and match color bars, limit the range. So if you want to plot just the oceans or just the land, there's a lot of stuff you can do. The GMT docs have instructions for doing all that. Okay. Yeah, you can do asymmetric color bars. There's a lot of fancy stuff with color bars in GMT that a lot of other plots don't have. Yeah. Yes, yeah, that still works. Yeah. 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 So for example, the geo color bar 0 will always be at that same color, even if you have. So for here, the color is scaled with the interval of the data. But with the geo color bar, 0 is always going to be the same color. So here, if our data went all the way to 8,000, 0 would be a different color, because the thing would be scaled to the range of the data. But some of these CPTs, particularly the ones for topography, 0 is kind of fixed on that one color, because you don't want suddenly your oceans to be green instead of being all blue. Okay. And I don't know any other software that does this. Actually, it's very convenient, particularly when you're plotting topography, because otherwise you have to keep track of always keeping the 0 in the middle. GMT does that automatically. Okay.
Can you override some fields and make them like NAM in the, you have to use like grid map or something like that to manipulate the grid?
Yeah. So there's a lot of manipulation you can do with the grid. You can cancel out elements. You can resample it at a higher, at a smaller grid space. You can filter it, and you can also remove some points by masking.
But that's not with gradient, right?
Yeah, that you have to do that separately. Yeah. Okay. So we didn't quite get to that plot. Yeah. So we didn't quite get here, but yeah, let's try to blast through this in the end. But like, there's instructions for this in the docs. I didn't know how to do this until a while ago. So it is possible to learn. You have the basis now for actually reading the docs, which is kind of challenging at first when you don't know how to read it. Okay, so let's try to do this. The thing we're doing here is we have grayscale in the continent, and we have the oceans in blue. So, right, so how do we do that? So, did anyone? Oh, okay. So let's do. So the one command I was mentioning was make CPT, which lets us configure the CPT. So the color bar, the color mapping. So I'm gonna configure the abyss color map to go from minus 10,000 until 0. So I don't want to plot the continent part. And now instead of using the abyss color map, I'm going to do -C, which is going to tell it to use whatever make CPT created. All right, so make CPT creates a custom CPT, and just doing -C tells GMT to use whatever was just created. Now, if I do this, my color should end at 0. So the land should be all one color. Right, so land is all white. It's shaded here because I told it to do shading. So instead of here, let's do 6,000 so that it's not too bad. Now, the other thing we have to do is cut out the land of Antarctica. And another superpower that GMT Coast has is you can tell it to start clipping the land. So if I say I'm gonna isolate the water. So if I do -SC, that's gonna tell it to whatever goes next, it's gonna cut out all the land part. And then I can do GMT Coast -Q to stop the clipping. Okay, so we're gonna post all these scripts on that GitHub page. So don't worry if it's too fast. So now we have cut out here the land. Okay. So what we can do next is plot the land and cut out the ocean. So how would I do that? I can do the exact same thing. So I'm gonna make a CPT, but this time I'm gonna use the gray CPT. Because Antarctica is kind of grayish, so we're gonna do gray. And I'm gonna do from 0 until, let's say 6,000. Now, same thing, GMT GRD image at Earth relief 0.5M -C -I plus default to get the shading. But I have to cut out the land now. So GMT Coast. Remember, to fill the water was -S, and to fill the land was -G. So the clipping is the same command. So if -S clips out it retains only the water, -G retains only the land part. And I have to end the clipping with -Q. So this should plot the land. And it's going to take a while because it's plotting the grid twice. Okay? So now we've gotten close to that. The one thing that's different is that the colors here, the range of colors for the gray is different. Because for that image, I wasn't doing from 0 until 10,000, in which case 0 would be black. But if I want 0 to be somewhat grayish, I could do from minus something until plus 6,000. So if I do minus 6,000 until 6,000, that should give me from grayish to white. Right. Okay. Or?
You can say the two gray levels are the end of the gray levels instead of saying the gray color. You can say start color, the end color on the -C option.
Yeah. So the two things that are missing here are plotting two color bars. So if I want to plot two color bars, what would I do? I can do another call to GMT color bar. So if I call them with the exact same parameters, they're going to plot one on top of each other. But the same way that you move the inset, you can also move the color bar. Right? So I'm not going to do that now, but you could move the two color bars so that they are not overlaying each other. And you could also overlay contours onto this if you want by calling GMT GRD contour. Okay? Right, so we got, this is pretty close. It's just missing the contours on land and missing the two color bars, but we're going to post a full script to do this later so you can have a look. Okay? So what are the questions that you have about grids or contours? Oh, yeah. Sorry. Put the code. Yeah?
When I did the contour example before,
Uh-huh.
I left out the word GRD.
Uh-huh. Really?
Yeah.
So you did just GMT contour?
I just did contour. GMT space
Huh. Let's check.
all tools without you call it a script. They run a script called tools that you
Yeah, I don't know. It doesn't work for me. No, we thought we got a free feature. Didn't implement it, but it worked, but maybe not. Okay, sorry. So this was the code. And the same, so for all the people who are gonna stay on for the INSAR workshop, all of the INSAR images that you're gonna work with, they are in this netcdf format. So these same commands that we're using here, GRD image, GRD contour, and the clipping and stuff like that, you can do the same thing with all the INSAR imagery that you're gonna be generating in the rest of the week. Okay. So for example, if you want to plot the image for California, but you want to leave out the parts that are off coast, now you know how to exclude something from the coast or exclude the oceanic parts if that isn't already excluded from the data. In the GitHub page, yeah. We'll send an email to everyone reminding. Yep. Okay, so some of the final remarks is don't throw these away. So before you leave, on the yellow sticky note, please write one thing that you thought was good about the workshop and that it worked. And on the red one, please write something that you didn't like or didn't work, or so one positive, one negative critique, and we'll collect those at the end. Yeah. And if you need more stickies, we have plenty.
Now it's saying that
What? Ooh.
yeah.
Ouch.
Yeah.
Yeah.
Okay, this one.
You actually do not really free stuff
The one on Google Drive? Yeah, yeah. So I limit the color bar as well in color bar. That's an argument in color bar. So you can tell it. Oh no, there's I don't remember the exact option, but one of the options to color bar is to cut it short. Yeah.
You didn't say that, right? Just
minus SC, minus GC.
So minus SC clips all the wet parts. So everything that's wet remains.
Can you put that as a comment in the script that is gonna get authoring it?
Oh yeah, sure.
Okay.
Work on this script a little bit, put some comments and speed them off.
Yeah.
I thought that I knew GMP, of course. You guys know it, that's like nobody else.
Throwing away half of the script. Because the first half was
like you said, it has a
was what I was missing. Okay, specify the first one.
And that's also one thing that we would welcome feedback on this, is like how to improve the documentation. Because as you've seen, like sometimes we struggle reading the documentation a little bit. So if you read something in the docs and you don't understand it, don't think that it's your limitation. Think of it as, okay, we should explain this better. So please tell us about it. So if you find a section in the docs and it's baffling and you cannot understand a single word, tell us about it, because we need to know where the problem sections are so that we can try to improve them.
So my only comment would be, I mean, how to better link kind of like the examples in the code book with the documentation. That, I mean,
that's one thing that we're working on, is how to have the documentation automatically link example plots with the commands that they were using. Yeah, that's one of the things. So one last thing before you leave. So let's say that you're trying to do something in GMT and you come across, for example, that missing -c here that just hangs, right? And you don't know what's going on. You check your code. You have the right code. It should work, but it doesn't. So how do you tell us about it so that we can fix it? So the website you have to go through to is github.com, or if you Google GMT GitHub, you should get to this page here. So this is where all the development of GMT happens. And there's this tab called Issues. So if you click here, there's a button here called New Issue. And you're going to need to register for a GitHub account. It's free. So if you click on New Issue, we're going to have several templates here. And if you're reporting a bug or something that you think is a bug, click here on Get Started to report a bug. And then you can tell us what happened. So describe what happened in the title. Describe with as much detail as you can what are you getting. And if you can, please paste your script here. So where it says paste code here, copy your script and paste it here so that we know exactly what code generates the problem. And if you get an error message, please copy and paste it here, because the error message will tell us where to look. And also, if you can, please fill out the operating system, what version of GMT. So all of this helps us track down the problem. If you come up with a problem and you tell us just like, oh, there's a problem, but you don't say what problem, what you were doing, there's no way that we can help. So the more information you put in here, the quicker we can solve the problem. Okay? So we'll also go back one. Yeah.
List of issues.
Oh, sorry.
So you can see we've posted several issues already here. Antarctica code gives bad region. The first time we tried to make that map broke. So that's been fixed already. And we have Joachim posted one here that it didn't behave the way it should work. Here.
Yeah, there's a new, someone asked about.
Come up during this session that we realized, oh, that's stupid. We got to fix that. Or this is a bug, we got to definitely fix that.
Yeah. Okay, so.
If you go back a little bit, it says code.
Yes.
And then there are different versions. There's like.
So this is the. So all these files, this is the source code for GMT and all the documentation as well.
Is that like the trunk, or is that?
That's the trunk, yeah. So this contains all the history of GMT going back maybe 15 years. So every single change that's ever been made in GMT for the past 15 years are registered here. And so this is how we keep track of everything and keep developing.
But if you were just want to install the stable one, you wouldn't install the master. You might install it right.
Oh yeah, yeah. So one of the instructions we have here is for installing, and that's going to tell you to install one of the stable versions. But there's also building, which is how do you compile the current source code. So if you want to dig down into this, feel free. It's an open project, which means that you can voice your opinions. If you come across something that you wish GMT did that it doesn't, one thing you can also report here is instead of saying, well, this is broken, you can say, I'd really like it if this happened in GMT, and that's a feature request. So if you click on Get Started, the template here is a little bit different. So please read the template here and try to fill out as much information as you can. Same thing as with bug reports, the more you tell us, the more likely it is that we can help and solve the problem. And the one thing that we're also asking is if you're willing to write this code yourself. And we will help you. You're not going to be stranded on a desert island and have to figure out how to do everything by yourself on your lab at home on your computer. We will help you through this online forum to make this contribution. This is particularly helpful for sections of the documentation that are difficult to understand, or sometimes they might even be outright wrong, where we're saying something happens and it doesn't. So please open these reports and tell us about it, because we can try to fix it, right? So this is a living project. It's not a static thing. And yeah, any help that you can give, it's good. Paul, any other closing remarks?
No, we'll have pizza and we'll get at it tomorrow again and do more complicated fancy stuff.
Yeah. So for the online people, no pizza, but maybe a night sleep or a day sleep. Yeah. No free pizza. Okay, so thank you, everyone.